Welcome to the Automotive Future of Automotive IT Conference, an update on autonomous vehicles. We have some great speakers with us today, and we're looking forward to the discussion of where we are today on autonomous vehicles, and of course, where we're headed over the next probably 5 to 10 years. My name is Bruce Belzowski. I'm the Managing Director of the Automotive Futures Group here in Ann Arbor, Michigan. And I'm going to give you a little introduction to the program and our speakers and some of the recent research that we've been doing on this topic as well. Automotive Futures Group. This is the group that I'm running. I'm the director, retired from the University of Michigan Transportation Research Institute in 2018, started Automotive Futures outside the university. We've got three major sources of our funding: our affiliate program, our research projects that focus on globalization, powertrains, and ITS, intelligent transportation systems, as well as information technology in the vehicle and inside the company, and our 5 annual conferences. We always like to thank our affiliate members for their support. Without them, we could not do our conferences. We could not be doing what we're doing in our research as well. And again, we like to thank them. For our research partners, we cross a lot of different groups. We look at IT organizations, OEMs, government and NGOs, as well as automotive suppliers and the major consultancies. Our major research projects look at powertrain strategies for the 21st century. We just finished our 2021 survey that we previewed the results at our powertrain conference in July. Our China New Energy Vehicle project, we're actually calling it our global EV project, and you'll see some results from our research on that today. New mobility, looking at IT, technology, policy, and innovative business models, particularly at our conferences. We'll have a new mobility conference coming up again in February of 2022. We just finished our research project on Tesla, where we asked industry experts about their views about Tesla. And then we have some autonomous vehicle stuff that came out of that I'll be talking about in just a little bit. I said the global EV project that focuses on not only China, but other countries as they're developing their EVs. Globalization of the industry, we look at a couple of different areas. Recently, we had a conference that looked at the effects of the pandemic on supply chains and globalization. And our 3rd annual U of M Automotive Student Survey that's coming up this year. We asked U of M students, I think we have usually about 20 to 30,000 in our 20 to 30, 2 to 3,000 students from our data set from all the university students, which is usually around 20, 30,000, and asking them what they think they're going to do in the future in terms of vehicle purchases, but also things about what they know about the industry, kind of like their, we would call it their automotive IQ. We use a lot of students in our research. Here's a list of our students. As you can see, they cross a lot of different areas: economics, engineering, statistics, even psychology and political science. And Kara Elkire, who's online right now with the following the YouTube stream that we're doing right now. She's following the any questions that come in the chat as well that will add into our Q&A sessions. For about a year now, we've been posting 2 to 3 times a week on our LinkedIn page. We try to give insight into what's going on in our conferences, also what's going on in the industry, insights from our research that we try to put up on the YouTube site as a way of trying to keep people up to date on the work that we're doing. So please feel free to join us, to connect with us and follow our page. Upcoming conferences on November 17th, we'll do our 14th annual Inside China Automotive Conference, looking at what's going on in China. And there's a lot of stuff going on, as we all know, as they're going on everywhere. And in February, we're going to do a new mobility conference that we've been doing a new mobility for the last, I think, 4 or 5 years. We're going to do a goods movement this time, kind of looking at the revolution of goods movement and also some of the challenges of goods movement that we're seeing in supply chains in the auto industry in particular, as the challenges of ports and the pandemic and its effect on the movement of goods. Here's the logistics. We've got our presenters, Tom Jellicoe from TTP is going to talk a little bit about sensors and his company. Joachim Teiber from the International Transportation Innovation Center, part of, and I think it's part of Clemson University. He can talk a little more about that with us. Robert Zidek from Toyota Research Institute. He's going to be talking about the work that they're doing on autonomous vehicles. And Mircea Gradu from Velodyne LiDAR is going to be talking about, of course, what's going on with LiDAR. So we're looking forward to hearing all their presentations. We're starting out with Tom and then do a Q&A with him, then Joachim, and then take a break, take about a 10-minute break. I'm going to talk a little bit about our China research that we've been doing on autonomous vehicles. Robert is coming in for after that to do his presentation and then do the Q&A, and then we'll finish with Mircea as our last speaker, and we'll be done at about 12:30 Eastern time. The attendees, everybody will get a link to the presentations. All the people who are registered for the conference will be sending them a link to the presentations in this weekend. Affiliates will get this link, but they'll also get a document with a link to the review of the highlights from the conference. The agenda, speaker bios, registration lists, sponsorship opportunities, affiliate information, upcoming events are all on our website for this conference. This website I sent to you in the link, along with the link for the live stream. It's in that email. It's also underneath the YouTube screen where you can see the link to the website, as well as a link for audience questions. If you have a question you'd like to ask, there's a link that underneath that YouTube site, as well as in the email I sent you. You can ask it in the chat on YouTube, and Kara will capture it there, or you can enter it into that link for the audience questions. All right, I'll talk a little bit about autonomous vehicle companies and the role of the U.S. government. One of the things I wanted to talk about. Guidehouse Insights has done some work on trying to capture where companies are in their development of automated driving systems. They show Waymo, NVIDIA, Argo AI, and Baidu as some of the best leaders who are best equipped in the development of the technology. They said the contenders are Cruise, Motional, Mobileye, Aurora, Zoox, Nuro, Yandex out of Russia, and AutoX. Now, every list has its weaknesses, and there are companies here that are not here. And I'm sure there are companies who would consider themselves leaders as opposed to contenders. So this is one consulting company's view of where the companies fit. There's also companies that are considered the challengers, May Mobility and Gatik, and then the followers. And this is where the Tesla comes in. Very interesting position for them. So among the 15 ranked companies, Waymo is now considered as a top vendor of automated driving vehicles. Tesla had the lowest rank. And the ranking was focused on companies developing the actual automated driving vehicles rather than on companies directly commercializing autonomous vehicles. It's kind of a narrow thing there that they're using to describe the differences among the groups. The In the U.S., we've got a lot of things that are happening just recently. Argo AI secured a permit to start giving free rides to consumers in California. Too Simple said its trucks will use the rider system to maintenance sites as terminals. I know that Google is working with JB Hunt. Waymo is working with JB Hunt on autonomous vehicles on driving in southern United States. Argo AI and Ford to launch self-driving vehicles on the Lyft network by the end of this year. And Waymo's autonomous vehicles have already clocked 20 million miles on public roads. In China, there's the automated trucking company Plus announced it has completed a driverless demonstration of autonomous trucking technology. No human was aboard the company's big rig as it trundled along a 20-mile stretch of China's Wufengchan highway in regular traffic conditions. This is something new for me. I wasn't aware that this company Plus even existed. So there's some new things that are coming out all the time, and we'll talk about some more of the China story in what's going on in the during my presentation after the break. Baidu has robots run fast. You can really take a nap during your travel under circumstances. Baidu says it has achieved level 4 autonomy with its new robot runs fast branded robo-taxi vehicles. And some of the autonomous vehicle deal flows, investors have placed more than $8 billion into China's auto tech industry between 2020 and 2021. More than half of that total went to companies specializing in autonomous technologies, including Pony AI, Neolex, which I've never heard of, and WeRide. When you look at the U.S. and what the U.S. government is doing, of course, when we look at NHTSA, they're primarily focused on safety. So they're looking. They have the tools that they have is interpreting interpretations of what should be on the road, any exemptions, and notice and commenting, and notice and comment rulemaking, and defects and enforcement authority. So they have the authority to identify safety defects, allowing the agency to recall vehicles or equipment that pose an unreasonable risk to safety. And this is one of the things that's going on right now with Tesla, with their vehicles that are tending to run into parked safety vehicles that are stopped on roads. So NHTSA's plan, they're going to modify what it calls its 200 series of rules within the Federal Motor Vehicle Safety Standards, which is the Bible by which automakers certify their cars' protection. Since every seat would be a passenger in a self-driving car, NHTSA wants to apply the front passenger's crash test standards to what is now the driver's position. And the best news for companies like Amazon that want to use autonomous delivery pods, none of these vehicles will have to comply with occupant protection standards since there will have no seats. When you look at DOT, which has a much broader perspective for what's going on in terms of what their regulatory goals are, they're going to promote access to clear and reliable information for partners and stakeholders, including the public, regarding the capabilities and limitations of autonomous driving systems. They want to modernize the regulatory environment to deal with unnecessary barriers in innovative vehicle designs, and to prepare the transportation system. This is because they have a much broader perspective than just safety. They're working to improve the safety, efficiency, and accessibility of the transportation system. And of course, the Society for Automotive Engineers just recently this year changed some of the characteristics of the different levels that they have for driving automation. In particular, it's where you look at the SAE level 3, where you have some of the level 3 things that require when the feature requested, you must drive. That's one of the things that were different from what they were showing before. And there's some different in level 2 and level 3 as well. Some changes that have adapted to kind of the new ways that we're looking at autonomous vehicles. Let's look at some of the autonomous vehicle insights that we are getting from our research. This came from our Tesla survey, where we asked, we had about 70 experts talk about what they thought about Tesla from a variety of different perspectives, but this really has to do with what they were showing in terms of their, what they were thinking about in terms of autonomous capability. They don't expect Tesla to have fully autonomous capabilities by the end of 2021, when this was something that was predicted by the CEO. Okay, next slide here. They do expect them to be autonomous by 2031. When you look at autonomous vehicles from any manufacturer, they think that they're going to be pretty sure they're going to be available, or more than half of the respondents thought that they're going to be available between 2031 and 2040, but 30% thought things are going to happen before 2030. So you look at 82% before 2040, but that you can see that most of the work they think is going to show up in the 2030s. When you look at the comments that they made about Tesla's computing technology, they expressed the belief that while Tesla has an advantage in autonomous driving, there's some real limitations in terms of the development of autonomy. 38% of the experts explained that how the discussion of timelines for autonomous driving are complicated given the different levels of autonomy. Overall, most agreed that fully autonomous driving, L5, is a long ways away. 21% thought that they commented on the serious complications with autonomous driving, especially with different road conditions that are likely to delay implementation. And 17% believe Tesla has an advantage in autonomous driving that their competitors can learn from. And others commented that legal liability issues will delay autonomous driving. And finally, experts believe that Tesla's poor operations and management will hinder their autonomous progress. So it's a mixed bag for Tesla here in the responses, but it really looks at the legal liability issues, different road conditions, the challenges of L5. The last one, it looks at experts discount the on-road data being continuously collected by Tesla vehicles and making that vast amount of driving and real-world conditions available to machine learning and AI algorithms. When Tesla can pair 5G technology with Palantir data analytics, fully autonomous driving is a few software development cycles away, not decades. So here you can see we have some really different views of where we see autonomous vehicles heading. So continue look at this topic, and this is why we're here today, to talk about this topic. So I want to thank you for taking the time and listening to me, and I'm going to stop my sharing and move on to our first speaker, Tom Jellicoe from TTP. Tom is the head of autonomous technology at TTP, Europe's largest independent deep tech consultancy. He works with ambitious clients to invent, design, and develop disruptive products based on advances in science and engineering. And Tom's interests include LiDAR, vision, and sensor integration. He holds a PhD in optoelectronics from the University of Cambridge. Welcome, Tom.
So thank you very much for inviting me to speak today. So Bruce asked me to cover kind of developments in sensor technology for autonomous vehicles. I think where most of the action is probably around LiDAR. So that's what I've focused on for my talk. I guess anyone who is attended many conferences on autonomous driving over the last few years knows that there's normally a fairly heavy LiDAR section, and it seems today is no different. Later on, we'll have a speaker from Velodyne, who are really one of the pioneers of LiDAR as well. Hopefully, I can offer a slightly different perspective to some of the LiDAR talks you might have seen before, because I don't actually work for a LiDAR company. My company is a consultancy business, so we don't have a particular product or a technology to promote. Hopefully I can offer maybe a kind of impartial industry-wide view of LiDAR, where it is today and where it might be going in future. And it'd be interesting to do a sort of compare and contrast with what Velodyne think later, possibly. So I thought it'd be the sort of key questions that would be interesting to tackle in a talk like this is, I guess, fundamentally, what is LiDAR? How does it work? What does the technology landscape look like right now? And what can we expect in the future? Before I move on to those, I thought I'd add a bit of context to why I'm interested in LiDAR by introducing the company I work for and the work that we do. So as Bruce mentioned, I work for TTP, which stands for the Technology Partnership. We're Europe's largest independent deep tech consultancy, and we're based in Europe's largest tech hub in Cambridge in the UK. We have about 250 scientists and engineers who invent, design and develop new technologies and products as a service for our clients. And we've been doing this for just over 30 years. And we do this pretty internationally. Probably these figures are from last year, but I think actually more than 50% of our business is now in the US, but then we're also quite active in Europe and we do some business in Asia as well. My role at TTP is head of autonomous technology. So my team are focused in the technologies which underlie the sensors for autonomous vehicles and machines. To give some background, TTP did its first job in autonomous driving for one of the German OEMs in 2003. And back then, everything was about computer vision. So we actually did a job looking at automated road sign recognition way back when. But at least for the last couple of years, almost all of our focus at TTP has been on automotive LiDAR, both looking at the sort of core sensing technologies and some of the integration challenges around putting them onto vehicles. And there's a good reason why we do so much work in LiDAR, and it's big business. There's huge amounts of investment pouring into LiDAR. So I think going back to 2018, I think that was probably the peak in investor enthusiasm for LiDAR. Some estimates had it down that there were more than 75 LiDAR companies in existence. So these are all companies that kind of had an idea on how to make a LiDAR sensor and were able to raise enough venture capital to start a business. Kind of as Bruce introduced in his talk, I think since then our perspectives have changed a little bit. I think we understand the challenges of autonomous driving a little better and know that these vehicles are probably a little bit further out than we estimated a few years ago. And this has led to consolidation in the industry. So if we had maybe 75 companies in 2018, there's possibly a couple of dozen serious players left now. In the last couple of years, I think we've also started to see some potential market leaders emerge. I should add a disclaimer here at this point. Nothing I say here should be considered financial advice. I'm a technology consultant, so I'm interested in the technologies, but it is interesting to look at how the markets have reacted to these sensor companies over the last couple of years. So we've seen 6 companies undergo SPAC mergers for very big valuations, particularly for when you think there are a company specializing in one sensor, which goes into the sensor suite of an autonomous vehicle, and they're all achieving sort of billion-dollar plus valuations. Just looking at the SPAC mergers, there's a combined value of more than $10 billion there. And that's not including all of the venture capital money that a whole load of other companies have managed to raise in this time. So it kind of, I guess, looking at this list, kind of 2 questions spring to mind. The first one is, have the winners in the LiDAR market now emerged? When you look at the suppliers for any part of a passenger vehicle, there's normally maybe 6 to 12 suppliers globally, something like that. When you see 6 here that have raised this amount of capital, are we looking at the list of the companies that are going to persist now and go on to dominate? I think my take on that is possibly. I think, you know, it's going to be difficult to compete with these companies because they're so well capitalized now. But the caveat I would add is that I don't think we've really shaken out exactly which technologies are going to dominate. I think there's still room for innovation there, and I think we could still see some disruption in the coming years. I think that's still got a bit of a way to go. The second question that seeing these big numbers brings to my mind is, what do they need all that cash for? You know, this is huge amounts of money. Why does it cost so much to develop a LiDAR? And there's a sort of a relatively simple answer to that question. LiDAR is really, really complex. There are a lot of subsystems to get right. So I've tried to kind of break down a LiDAR into its fundamental building blocks here. And for those unfamiliar with this sensor, I'll just cover the operating principle. So a LiDAR is the laser equivalent of a radar. So it uses pulses of laser light. It sends them out into the surroundings of the sensor. When they encounter an object, some of that light is scattered back to the sensor, which it then detects. And by calculating the time between when you sent the pulse and when you got some light back, you can work out the distance of the object you hit, because you know the speed of light. So that's how you measure a point with a LiDAR. If you then do this sort of over 1 million times a second, you can measure the 3D scene around the sensor. And what's so useful is it's a direct measure of the distance of all of the objects there. Unlike a camera where you're trying to infer from a 2D projection of a 3D scene where things are, in LiDAR you measure it directly, which is why it's such a valuable measurement. The challenge is that there's a lot of technologies that you need to get right in order to be able to do that. So just kind of working around these blocks, you need a laser which can produce very short pulses of laser light, so down to sort of 10 billionths of a second duration. So they have to be very precise. You need optics which shape these pulses so that they behave themselves when they go out into the world beyond the LiDAR sensor. You need some sort of steering system to direct the pulses to all the points that you want to measure in the surroundings. And then on the other side, you have your receiver optics that need to collect all of the returned light, a detector which needs to turn that into a signal large enough to measure. And then you need an electronic chip to a sort of a brain to control this all, to coordinate both the pulses that you're sending back and the signals you're receiving, and do all the calculations and turn this into usable data for the vehicle. So this is a big challenge. You know, if you're making a scientific instrument that was supposed to sit on a bench in a lab, this would be tricky. But instead, we're trying to do this in a box which is then fitted on the exterior of a car. And there are some specific challenges relating to automotive which make this extra tricky. One of them is, and probably the biggest, is cost. The challenge with putting this into, you know, conventional passenger vehicles, which you might buy at your local dealership, is that the cost of a luxury vehicle has been relatively fixed for the last few decades. If you look, each generation of a vehicle will often have an upgrade in the technology and the features, but the cost stays relatively fixed. It's not possible for OEMs to start adding loads of cost onto their vehicles in order to add these features. They need to do them at an acceptable price point to consumers, which makes it really, really tricky for the LiDAR companies, because ultimately the OEMs would like to be paying about $100 for this sensor. To put that in perspective, you know, in a LiDAR sensor, you've got kind of in the top row of these boxes, you've got a laser projector which has to have centimeter resolution at kind of 250 yards. And on the bottom, you've got a very precise camera that needs to take millions of pictures per second. And you've got to do this all for 1/10 of the cost of an iPhone. It's a really big challenge. Another challenge is the range requirements. So vehicles drive quite quickly, particularly on freeways. So you need to measure quite far down the road in order for the vehicle to have enough time to react. And this is another challenge. This really pushes what you have to do with your signal processing in order to get usable information. And then there are a whole bunch of other challenges related to integrating these into cars. You want to make the sensor as small as possible so that it's easy to integrate and it doesn't affect the aerodynamics too badly. You need it to operate in all the conditions where you're likely to drive a car. So whether that's, winter in Canada or summer in Saudi Arabia, it needs to be able to deal with all of those temperature ranges. The reason this is particularly tricky for such a precise optical assembly is because all of the components in this are made out of slightly different materials, which all expand and contract at different temperature ranges to a different extent. So, if you make a system at room temperature, it might distort out of shape slightly and misalign everything when you go up to high temperature or low temperature. So you have to engineer this to be resistant to this. And then the final point that makes this really tricky is that it needs to survive often on the exterior of a car for up to 10 years. And that's not a particularly hospitable environment for complex electronic devices. So it's a really tricky challenge. But when you get it right, it's super useful. This is some point cloud data actually of the entrance to our building in Cambridge, and you can see you get quite a detailed 3D map of the scene. Here you can see the pedestrians, you can see the cars, and you can kind of see the shape and outline of the building, which is all really useful information when you're trying to operate a vehicle autonomously. So I thought I'd that's why LiDAR is important and why it's useful and some of the challenges. I thought to give a bit of a landscape of where the technology is now, the best way I found to try and understand the kind of diversity in devices and how things have progressed over time is to split LiDAR into generations of devices, and they're ultimately split on how they move their light around, so on their beam steering system. So the first generation of devices, which have been around for a while now, really largely pioneered by Velodyne, I'd say, are the mechanical scanning LiDARs. So to create to measure your 3D scene, you need to measure in 3 dimensions. So you get the distance dimension from the LiDAR measurement, but you need to measure up and down and side to side. The way these generation 1 devices work is by you get 1 dimension by stacking the lasers and detectors on top of each other, all kind of facing in a slightly different angle. So you measure lines. And then the other dimension is by motor actuating it. So you spin all of these lines around in a circle, and that way you can measure a 3D scene. Mechanically, these are probably the simplest of the devices. But by adding all those lasers and detectors and stacking the components on top of each other, you add quite a lot of cost to the device. So these things, they started off at kind of $70,000 to $80,000. Now they're probably down to around $10,000 ish, which is probably a bit too high for conventional passenger vehicles where there's high volumes, but it's really useful for things like robo-taxis and other commercial applications which can support a higher cost for the sensors. After generation 1 came the second generation, and the big difference here is that instead of scanning the beams in 1 dimension, so just kind of spinning them around in a circle or oscillating them back and forth, you can now scan the lasers up and down and side to side. And what this means is that you don't need as many lasers, you don't need as many detectors, and you don't need all the drive electronics behind it, which interpret all the signals and do all the calculations. And this massively reduces the cost. So maybe by an order of magnitude or a factor of 10. And this is kind of the sweet spot for LiDAR at the moment. These are the companies that are getting the big deals with the OEMs and making big headlines. They're the guys that have raised a lot of money in the public markets, and they're really quite far out in front at the moment. I think two very good examples are Innoviz and Luminar, who have both announced substantial deals with BMW and Volvo, respectively. So if this is the sweet spot, are these guys going to dominate forever? I would say there's probably room for new technologies still, because while these guys are very much there in terms of the performance that's required by the OEMs. They're still a ways off on costs. So there's kind of a third generation of devices which are coming, which are potentially quite disruptive in terms of cost by really simplifying the system. So in generation 2, we're scanning the beam in 2 dimensions. So there's quite a lot of mechanical complexity to this. In these generation 3 devices, they're fully solid state. So they have no moving parts. They no longer have to scan the beam because they have all of their lasers and all of their detectors integrated into a single chip each. So instead of having a laser and a beam steering system, you can just have a chip of thousands of lasers all pointing in a slightly different direction, and you can use this to measure the scene. Because of this simplicity, it means they are potentially much lower cost because there's just much less complexity in them to engineer. But the technologies which they're based on are a little bit less mature, and I'll dig into that in the next couple of slides. So here's my schematic of a generation 2 LiDAR. So in this kind of cylindrical bucket, that's where you'd have your lasers, detectors, and your drive electronics. They typically use pretty technologically mature laser systems and detector systems, things that have been developed in other industries and are now used in LiDAR. So from that perspective, they've got quite mature technologies. The big challenge they have is scanning the beam around in 2 dimensions. And this tends to be where the companies differentiate. So here I've kind of schematically shown it as 2 mirrors. So maybe one goes side to side and one goes up and down. In a lot of cases, this is really where the core IP is for these sorts of companies, and this is where they compete. They have some clever way of moving the pulses around and measuring the scene. This is really key to the system in a lot of cases because it determines not just the resolution but also the range. Because as you make your beam steering system larger, you can send and receive more light, so you have stronger signals and better range. But the challenge is as you make things bigger, they're typically more difficult to move quickly. So there's this kind of trade-off that these guys have to navigate. I thought it might be useful to show you what this system actually looks like. So this is something that we work with generation 2 LiDAR companies on at TTP. We have our own clean room fabrication facility, and we've developed a beam steering system for a LiDAR, and I thought I could show you a video of it. So on the left, hopefully you can see an oscillating mirror. So this is a mirror that the laser is pointed towards. And then on the right, you'll see a red spot that bounces back and forward. This looks relatively sort of unimpressive on this video because it's slowed right down. But this was actually recorded at about 2,000 frames per second. So this mirror on the left oscillates. It does 2,000 of those bounces every second. And if you imagine you can do that in 2 dimensions, you can measure a whole scene. So that's kind of where the generation 2 guys are and what they're competing on. The next is the kind of contender technology, generation 3. Here's the best schematic I could come up with for how these LiDARs work. So instead of having a laser beam which you scan around, you have a single chip with thousands of lasers patterned on it, all which will all project kind of a series of spots in the far field, and then you have a matching detector chip with lots of pixels on it which measure each of these spots. So now instead of needing to scan around with your laser, you can kind of send the light in all directions. The big challenge they have is that these laser systems and detector systems are a lot less technologically mature than the equivalents used in the generation 2 devices. To give some idea on performance, the VCSEL lasers used here produce about 1/10 of the light per unit area of the generation 2 lasers. So you need a lot more of the optical semiconductor to get the same performance. So what these guys really want is improved lasers and detectors. We work with these companies too, developing quite clever optics to try and manage this light a little bit more carefully. So make sure all of the light goes to exactly where you want it to, and make sure you detect as much as possible in a smaller unit area. But fundamentally, to scale these technologies, they need the big optical semiconductor companies to invest in the processing of these VCSELs and SPADs. So I guess I've kind of talked a little bit about generation 2 and generation 3. And the question I often get asked is which technology is going to dominate? I guess as a consultant that works with both generations of companies, it's probably not a clever idea for me to kind of pick a side in this. But I do think that the automotive industry is incredibly cost constrained. I mean, the number of times we've spoken to OEMs, and if you can improve performance by 5%, but it increases cost by 10%, it's a non-starter. You always have to improve on cost, and you have to achieve adequate performance. So I think if generation 3 lidars are able to get to that performance specification required by the OEMs, then they'll be really quite difficult to compete with. They have a small they might be getting some help as well from another industry. So I think it was maybe about 2 years ago now, I think it was last year, Apple announced that they were putting a flash LiDAR into the iPhone 12. So the LiDAR they're using is based on exactly the same lasers and detectors as these generation 3 LiDAR systems are. I'm sure you will remember when digital cameras first went into mobile phones, and we went from sort of half a megapixel to like 16 megapixels in like a matter of maybe 18 months or 2 years. As soon as you start scaling in consumer product volumes, then you end up with a lot of research and a lot of development into the key components for that. If the same thing happens for these light emitting components, that could be very valuable indeed to the generation 3 LiDAR companies. Another kind of a development which could signal an improvement in those technologies is that 2 of the larger VCSEL suppliers have made moves towards automotive in the last 18 months or so. So AMS, who make a lot of VCSELs, have acquired Osram, who I think are one of the largest, if not the largest, supplier of light emitting components to the automotive industry, and also Lumentum, who are rumored to be providing their VCSELs to Apple, acquired the IP assets of an automotive VCSEL manufacturer. So it looks like if that really does scale, then that will make these generation 3 lidars really competitive. If the OEMs do get their dream of the $100 lidar, which hits their performance spec, then suddenly they'll become quite ubiquitous in passenger vehicles. So I think that's about everything I wanted to cover today. I just wanted to sort of double down on some of the key messages. I think, understanding the LiDAR landscape, it's really these generation 2 2D mechanical scanning systems, which are very dominant right now. They've got the big deals with the OEMs, and they've got a lot of cash in the bank. There's huge potential for these Gen 3 devices, but the big if is whether the optoelectronic components they rely on really scale, whether they improve in performance and reduce in cost. Ultimately, the winner will be the technology which really achieves adequate performance, but at the lowest cost point. And with that, I think I'll finish. Thank you very much for your attention. I'll be happy to answer any questions you've got.
Thank you very much, Tom. Stop sharing your screen. There you go. Very good. We've got some good questions for you. One of the things that jumped out at me in your discussion was something that I've been reading about LiDAR, is something called 3D LiDAR. And does that fit into the things that you've been looking at?
So it's funny, depending on the company you speak to, lots of people define their dimensions differently. I've seen some companies define their LiDAR as 60 by adding reflectivity and velocity. So if you measure it in a certain way using continuous lasers, but frequency modulating them, then you can also get the velocity of the object you measure. I think it really depends on how you kind of define your coordinate system. I guess there's kind of a question here of what the actual need and what the use case is. What information ultimately the OEMs and the tier ones really want from the LiDAR. Do they want just 3D positional information of all the objects around it? Do they actually want the velocity information? It really, At the moment, it seems that the key information that a LiDAR has to provide is 3D position, and that's kind of it. I'm not sure how much the reflectivity data that's contained within it's used, and I'm not aware of too many RFQs from OEMs requiring velocity information too. But yeah, I guess there's so many companies, everyone kind of needs to differentiate somehow. So maybe adding dimensions to their sensor is the way to do it.
Okay, thank you. One of the people online asked the question, what size of a module is realistic for a LiDAR used in ADAS applications rolling out in the next few years?
So they are getting smaller. And it really, I guess it depends on the technology. There's quite a big range of sizes. So there's a German company called Blickfeld who have got a very small LiDAR. It's kind of like maybe 2 inches by 5 inches or something. It's a tiny box. And then some of the larger, higher resolution ones have a bit more componentry in them, so they tend to be a bit bigger. They're getting smaller, but it doesn't seem to be the key driver of innovation at the moment. I think in terms of the list of improvements that the OEMs want, and therefore the LiDAR companies want, really improvement on cost is absolutely top of the list. And then kind of reducing the size is a nice to have underneath that.
Well, it's nice. You are definitely sounding like someone who's working with the manufacturers when you start talking about cost. You can always tell this is not a pie in the sky story when people start talking about cost.
Yeah, cost is absolutely everything. I spent early on in the career trying to sell technologies to automotive companies. I spent a certain amount of time trying to sort of banging my head against the wall, trying to show kind of new features and stuff you could add that added cost as well. And The key is always cost has to stay the same or go down. And it's kind of a bonus if the performance improves.
Now, Tom, you guys also look at some other sensors that are used in autonomous vehicles as well. You didn't touch on them very much. And is there something you want to talk about the other sensors that are part of the package? And also, what's the sensor fusion story?
Sure. So I think as I sort of mentioned at the start, most of our work is in LiDAR because there's just so much investment, and the complexity means there are tons of kind of physics and engineering challenges to be solved there. But that's not the only sensor in the sensor suite. We've got a pretty rich history in computer vision, working with cameras. As I mentioned, that started more than 20 years ago at TTP and has really continued through and is a strength that we have. I think one of the really interesting sensing modalities that we're looking at the moment is thermal imaging, so thermal cameras. So this uses long wavelength infrared, and it kind of gives you slightly different data to some of the other sensors. Thermal cameras, effectively night vision, has existed for a long time, but what we're kind of interested in is the specific integration challenges about putting these sensors on vehicles and using them in robust autonomous systems. So one of the particular challenges, the unique challenges about using, night vision cameras on a car is that, typically you have to protect your sensor from the elements, from wind, rain, dust, dirt, flies, other bugs, all sorts that it gets buffeted with on the exterior of a vehicle. When you use an optical sensor like a LiDAR or a camera, you can put kind of a toughened piece of glass or something like that in front of it. The challenge with night vision is that the cameras to a night vision camera, a piece of glass or a piece of plastic is completely opaque. You can't see through it at all. So you have to come up with clever ways to integrate the cameras so that they stay clean and useful. So that's another thing that we're working on is ways to keep the cameras clean that don't use kind of glass, plastic, or often liquid feeds as well.
Okay, thank you. Another one of the questions is, generally speaking, is one LiDAR unit sufficient in the front of a vehicle to create a comprehensive map of the forward environment, or are most OEMs looking at multiple units? And by extension, is there a perceived need for redundancy and overlap for safety reasons?
Yeah, I think so. Quite a few years ago, I think ideally the OEMs would have liked kind of an all singing, all dancing LiDAR that produced, had really long range. You could see all around the vehicle, was, did everything. And I think, we know now that that's really challenging to do. So I think there is kind of some differentiation there, and that you often have a very kind of precise long range sensor that might be in the top of the vehicle looking a long way down the freeway, and then you have kind of shorter range but wider field of view sensors around the vehicle exterior. So I kind of presented these generations of LiDAR kind of almost being in conflict, but one could imagine maybe a generation 2 sat in the middle of the roof of the vehicle, and maybe some of these lower cost shorter range sensors around the vehicle exterior. But I guess everyone kind of has a slightly different way of putting together their sensor suite. Some people use one LiDAR, some people use many LiDARs. Some companies prefer to use lots and lots of cameras. So it really depends on the company and how they design their sensor system to be robust.
Okay. Yeah, you could see that, and I think you mentioned it already, that the performance specifications seem to have changed over time. So, and they're probably still not fixed, right? There's probably still potential changes in what's going to be required in terms of performance. But again, there's all this balance between cost and performance, right? And
yeah, exactly.
But then you still have the safety story. How safe are you, right?
Yeah, and I think one of the things that's been learned over the last few years is the complexity in LiDAR makes it really challenging to take it through automotive qualification and into actual passenger vehicles. We've been learning so much over the last few years of actually trying to build, thousands of these devices to automotive quality standards. Effectively what you're trying to do is take something that looks kind of like a scientific lab instrument and turn it into kind of a robust automotive product. It's got kind of pulsed lasers, tiny mirrors, it's got all of these mechanical components that all have to be in perfect sync, and it has to survive on a car. It's really tricky, and over time we're kind of learning what's required to get that through, but fortunately, I think a lot of that learning has been done now, and I think we have a much better idea of what's really possible for a given price point.
Robert, do you have any comments about the discussion on LiDAR?
Yeah, first of all, it was a very great, interesting talk. And yeah, I think my current sense is that a lot of companies in the AV industry are trying to reduce their dependency on LiDAR. Because of the points that Tom really raised. Cost is the biggest one. So it's going to be, I think, very interesting because they're spending so many resources now on reducing dependency on LiDAR. But then maybe if the LiDAR technology really makes big improvements and reduces in cost, 10 years from now, LiDAR is basically a commodity that everybody can use. And the amount of effort AV companies are spending now to reduce the dependency on LiDARs is kind of, in vain. So maybe, Tom, you can comment a little bit on that.
Yeah, I think, as you say, it's all about reducing the total system costs. So not just the LiDAR sensors, but the whole sensor system and all of the, all the hardware that needs to run the software stack behind that. So it's kind of up to the LiDAR companies, I guess, to some extent, to make their products desirable and useful. And if they're failing on that, then they will get designed out of vehicles. I think one of the challenges at the moment is the lack of standardization in LiDAR. Of all those companies that were kind of named in my presentation, all of their sensors work quite differently. I mean, I showed that LiDAR block and all the sort of subsystems that are required to make one. If you imagine you've got a few different choices on each of those, it means you've got thousands of possible combinations that actually make a LiDAR sensor. So there's this huge diversity in actually how the sensors work. And one of the challenges that presents is that, kind of as Robert alluded to, they're not really commodity sensors at all at the moment. The data coming off to LiDARs is not the same. So it means that actually the LiDAR companies ending up having to provide quite a lot of software with their sensors, because they're the only guys who really understand exactly how it measures the world, and when they're the guys who understand the best about how much you can trust it. I think if we move to a situation where it does become, where we settle more on one technology, it becomes more commoditized, then it's possible to invest more in in software which can work with multiple sensors, and the whole kind of cost argument becomes a bit easier. If you have a choice of a few different suppliers that produce a very similar product, then you're going to have more purchasing power, and also you can produce software which can port between sensors. It makes the total system cost quite a lot lower. Well, the timescale for that kind of shaking out, it could be quite long though, because the challenge is there's all these different LiDAR companies, and they've all got a lot of cash in the bank, so they've got enough capital to keep going for some time. So it might be a while before LiDAR really standardizes.
Yeah, and I think that what you're seeing in the auto industry is that there are the traditional companies are basically putting these programs and these technologies into they're still R&D. These are all. This is still R&D. Robert works for an R&D company, R&D section of within Toyota, and they're not on vehicles yet. So this is why all this stuff is still anything can happen in terms of development. Joaquim, did you have anything you wanted to add to the discussion?
Yeah. So what I think is important, we heard a lot about the emphasis on cost, but what I would like to add is we also need to get the customer feedback, right? So, I mean, I know that at least Tesla made this approach that they charge extra for sensors for future implementation. So I was wondering whether it's really just only the cost, or whether we have systems that reach the customer for feedback. Is there any direction that you see right now? As how close are we there? So are the Generation 3 systems still in an R&D status where they haven't reached the customer, or when are they reaching the customer?
So the companies that I know, I think are kind of in fairly late stage, kind of proof of concept, early kind of pre-development with the automotive customers. I mean, I think some of the feedback I've heard from some of the OEMs is the real challenge is like you say, selling these things to the end customer. Someone from Daimler told me that in North America, the ADAS package as an optional extra, I think it's slightly less expensive than the massage seats, and massage seats outsell it kind of 10-1 or something. So it is a real challenge actually in kind of driving adoption amongst the people who are actually paying for it.
Yeah, what I meant was that when it reaches the customer and you get feedback, then you actually know how much you can charge right now. So it's difficult for me to understand why they are already obsessed by the cost before actually the customer has spoken, right? The customer may say, I like this feature and this functionality so much that I'm willing to spend more. And right now they are just making an assumption, right? So how much it should cost. So that was for me the missing piece. So,
we've seen some.
But maybe one thing. Oh, sorry, Bruce. I think one thing that to keep in mind here, I think the customer, a person who buys a vehicle, I don't think cares about if the vehicle is using a LiDAR or if the vehicle is just using cameras. The customer really cares about the underlying driving behavior or whatever can be achieved. The customer, I think, does not care about if the vehicle is using a LiDAR or a camera, I think.
Yeah.
Right. So it really has, and what we've seen is that a lot of consumers don't have any idea how this stuff works. And they don't even know, and they have trouble with just general ADAS systems, much less an autonomous vehicle system. And we can talk a little bit more about this throughout the day about the trust issues that that need to be developed within the consumer base to be able to make them feel like they really want one of these technologies. But every time that that I've seen research that asks customers how much they're willing to pay for extra technology, it's usually very, very little. they always want something for nothing, right? They always want it for as little. I don't want to pay any more. I mean, in their defense, the cost of vehicles is high. It's when you're going out to 72 months for purchasing a new vehicle, that vehicle better last at least 72 months, and they do. But it's a very different animal than what we've had in the past. Go ahead.
One more thought, Bruce, on this is in the electrification, in the electric vehicle purchase, we get an incentive. So there are subsidies but we are not giving incentives for safety systems, right?
Right.
So
that's right. That's right.
That could also be a debate.
Yeah, and it could be there could be incentives that maybe come out of that if you're trying to transition the populace to a certain type of technology. Maybe it would be worth it, right? It depends. All right, we've got Tom, you've done your duty. Please stick around and kibitz with us on the other presentations. And we'll go now to Joachim to talk about his research and what he's been working on. Joachim, let me give you a little introduction here in your bio. Joachim Teiber's academic training was at the Swiss Federal Institute of Technology in Zurich, in Switzerland, where he first graduated with a master's degree in mechanical engineering in 91, and then completed his PhD in 96. His career has covered a lot of ground, working with BMW Group in Germany on different aspects of functional integration and validation of vehicle systems, vehicle electronics platforms, and vehicle program management, and even helping create a Silicon Valley-based corporate venture fund and reorganizing an IT division. In 2010, Dr. Tabor joined Clemson University as a full-time research professor. In 2012, he created the Advanced Vehicle Infrastructure and Technology Institute under the College of Engineering and Science. And in 2016, he was appointed Chief Technology Officer of the International Transportation Innovation Center, a special purpose nonprofit organization headquartered in Greenville, South Carolina, focused on developing and applying innovative methods of system validation for connected, automated, shared, and sustainable forms of mobility, which is what he's going to be talking to us about today. Okay, Joachim, take it away.
Thank you very much. So just before I share my slides, I wanted to get some clarification because you referred to this before, Bruce. So ITIC, the International Transportation Innovation Center, which is the organization I'm representing today, is collaborating with the Clemson University International Center of Automotive Research, but it's not part of it. So we are partners, but we are still independent organizations.
That's what it sounded like when it was discussed as a nonprofit organization. I go, sounds like it's a separate, but has a good relationship with Clemson.
We have a very healthy and good relationship. Absolutely. Yeah. So I will start sharing my slides. So let me see that you can see that. I hope it works well. Do you see it?
Yeah.
Okay. Yeah. So what I wanted to talk today is the path towards standardized testing in autonomous driving and L4 certification from a global perspective. And I wanted to start first with how much actually resources and funding has gone into autonomous driving technology. So we see here in this chart that we have since 2010, so more than $100 billion went into autonomous driving, which is, if you compare the different categories of investment in autonomous, connected, and electrified driving, that's basically the largest portion of it. And what is now important that this has started, I think a very important milestone was in 2005, the DARPA challenge that all of you know, but that has been more than 15 years ago. And fact is that we still don't have L4 vehicles as a standard solution on the road. So it's a pretty long development. So just highlighting a few things, that in 2009, the Google car was presented. And at that time, the goal was to drive 100 miles uninterrupted. Since last year, Cruise, with their automotive vehicle program, is driving without test drivers in San Francisco. They started this activity just last year. We also had major setbacks, and I just highlighting two of many setbacks. One was in 2018 when, unfortunately, a person died by a Uber autonomous vehicle. That was a well-investigated crash that led obviously to some consequences and safety measurements needed for testing autonomous driving. And very recently, and I don't know any more details about it, was at the Olympic Games when a Toyota e-Pallet vehicle crashed into an athlete and injured him. So this is a long journey. And I think it is important to understand what are the major driving forces to bring autonomous driving to mass adoptions. So if we look from a safety perspective, we all would like to have 0 crashes on the road. But if we look at the statistics over the last 10 years, about the number of people dying in the traffic in the US, we don't see any major impact in the statistics. So of course, we would like to see this going to 0, but despite that long journey, we haven't seen any impact yet. So there's a big challenge and a big opportunity. The other important topic is that we all drive, we spend a significant amount of time in a car. And when we are driving a car, we shouldn't be distracted. That means that if we get self-driving to work, then we can free up a lot of time for the consumer, which is extremely valuable, both for the consumer, but also for service providers that want to offer services to this consumer. And then another aspect is we have a significant amount of people that are using rideshare services or driving services such as Uber. And at the moment, about 50% of an Uber ride cost per ride goes to the driver compensation. And obviously that would go away if you find ways to have the car driving autonomously. So these are the major drivers, but also what are the bottlenecks? So one of the key bottlenecks, which I think we all are aware of, is lack of regulatory guidance. So I would say there's a lot of regulatory activity, but still, at the end of the day, the question is, do we have the guidance? So the first AV guidance from NHTSA came out in 2016, so about 5 years ago. In 2020, so last year in December, I think, we got an ANPRM for the ADS framework from NHTSA coming out, which shows you that this goes pretty slowly. But considering that $100 billion have been invested already, it is very important that we have this regulatory guidance. Another aspect is the technical complexity. So we need significant computing capabilities, both in the car as well as outside the car. These chip technologies are being developed and are coming into fruition, but we are dealing with an extremely complex problem. We just talked about LiDAR sensors, and that's just one element of it. So sensing capability, so we have the complexity issue. And then if we look at the hardware and software stack, and the different applications related to self-driving technologies, we have a very fragmented ecosystem with many players, a lot of young companies, startups, some are of course established players, but it's a very fragmented landscape that needs to be consolidated over the next few years. And this fragmentation is another hurdle at the moment. So if we look at it from a regulatory and technology point of view, I think the SAE levels were already presented before by Bruce. So we are talking obviously about level 3 to level 5. And if we are looking into the deployment of these technologies into the vehicle fleet, it is important to understand that we will have for a long, long time what I call a mixed fleet on the road. So we don't have a switch where from one day to the next every car is self-driving. So we have a mixture. So some vehicles will not have any technology to interact with other vehicles. Some vehicles can interact with other vehicles, but don't have the self-driving technology. And then obviously we have new generation vehicles that then ultimately have level 3 to 5, but need to cope with other vehicles. And so this makes it quite challenging. So the building blocks and I'm just highlighting here a few things, are that we need to standardize driving scenarios and the description of driving scenarios. So in this particular example, we want to make a left turn on a roundabout. So it cannot be that one OEM has a certain understanding of the scenario and another OEM has a different understanding of this driving scenario. So we need standardized description that allow vehicles of any make from any OEM to interact with each other in a predictable way. And that requires standardized scenario libraries, which are being used in the simulation tools, but also obviously in the physical validation on the proving grounds and the test beds. And what we have seen in the market is that there are a lot of libraries around, but they are not yet standardized. There are a lot of activities at the moment to standardize them, but it's not that we have already a fully resolved situation here. So that's very important as a building block. Another important topic is that we need a very well understood reference process that allows us to correlate virtual testing with physical testing. So IAMTS, so International Alliance for Mobility Testing and Standardization, is an organization which I founded a couple of years ago together with the SAE, where we are analyzing this in detail and where we're making suggestions. How do you build up a tool chain? How do you validate the different simulation models, and how do you then map the virtual test tool chain with a physical tool chain, so to get to comparable results. Another aspect is, and I want to give you an example, how do you standardize testing? So do a very simple example. So let's just take a brake test. A brake test has in this case, different standards. So we have a standard in the US, we have a standard in the EU, we have standard, in this case, a standard in Japan. And it is well defined how to perform this brake test. However, there are still differences in these different standards between US, EU, and Japan, which means that you cannot just compare the results without being aware of these differences. And on the right-hand side of this chart, you see just an example of a a model how to describe an automated lane change. So imagine I want to test an automated lane change first in the simulation world, and then I want to test it in the physical world. So if the different players that do these tests have different models behind this, then the results will not be comparable. So we need to make sure that we have this comparability, coming back to the driving scenarios that I mentioned before, where we need standardized description models. Another example here is that let's assume we have these standardized test scenarios defined. So we need now to program this. So we need to link different scenarios together. A very nice example how this could be done is has been shown by MCity, where they have a visual programming environment where I can basically create certain test procedures first in the virtual world, and then connecting that with the physical test infrastructure. And again, if you connect it then in the right way, you can do the right correlation between the physical results and the virtual results. And you can imagine if one OEM does it in one way and another OEM in another way, then we have a problem. So we need to standardize this. Another important topic that I want to highlight is, at the end of the day, autonomous driving has to work in the real world. And that means in some discussions that I had with OEMs, it turns out that they are very focused on the geographical areas where they have the majority of their customers, and that will be different from OEM to OEM. So they have certain regions that may be very important to them and their customers. So we have to make sure that these scenarios are first understood in these high priority regions. So I mentioned Cruise before in San Francisco, so they focus on San Francisco. I think Waymo focus on Phoenix to learn there a lot in that environment. But over time, if you deploy this as an OEM, you need to go to many, many different locations. So you need, I call it an open test bed, where you validate the behavior close to the customer. You even may do pilot programs with customers, or you simulate the customer through your test drivers. But you need to validate that in a environment that is close to reality, and then bring those scenarios that are critical back into an enclosed environment and do there in detail all kinds of variations and technology validation. And so you need also to bring test data sets from the real world environment back into the closed environment to analyze it further. So this correlation between open test beds and closed test beds, I think, is very important in the journey of autonomous driving. Another aspect is to understand the limits of modeling. So you have certain situations, like here an example of a sandstorm in the desert, maybe in the Middle East, or in the north with ice and storm situations, where you simply don't have the exact simulation models for this. So there may be a need that if there's a test vehicle in these regions that encounters a specific situations, you need to link that back into your cyber physical environment to run the simulation models against what you are actually experiencing in the real world. And and that helps then also to further refine the simulation models. Another aspect that I wanted to highlight is the different views and what comes very often into the way are competitive forces versus what I call normative forces. So if we had, coming back to my first slide, $100 billion invested, there's a lot of competition. Everybody wants to be the winner, and doesn't want to share anything to the competitors, of course. Ideally, also doesn't want to share with the government because there's a fear that this could then go to the competition. And then also continuously showing the investors that their company is the best in that competition. That gives them the temptation to be overambitious and has the risk that then accidents can happen, or because you're under pressure to be the winner. On the other hand, you have the regulatory view, where they want to make sure that the road user is protected from technology risks, and that the technology is being certified against standards. But then obviously the problem is, if you're defining those standards, you need to make sure that you are not just favoring a specific technology, that you give room to different technologies to compete with each other and to work out what is the best solution. And then also you need to understand, at least from the road operator and regulatory view, what the infrastructure aspects are. And so because the better the infrastructure can support autonomous driving, that can have implications on the cost side, on the vehicle side. So one of the big risks that we have in the development of test infrastructure, and I have been involved in many of those projects over my career, is that you have incompatible infrastructures. So an OEM might be maybe investing hundreds of millions in a proving ground, and but then how can they don't share direct information what another OEM puts into his proving ground. So you need to make sure that there's some form of compatibility. Some proving grounds are owned not by OEMs, but publicly owned or by independent test operators. So we have to make sure that those proving grounds are following standardized scenario models and lead to comparability. So that's very important, and that has implications in how you plan and certify those facilities. Another element is resource sharing. So let's assume every OEM would build 100 miles of his private highway to test all kinds of scenarios for highway driving. Would be extremely expensive and maybe not make any sense. So it is maybe makes more sense that those test infrastructures are being developed once or a couple of times in different regions and then shared by an ecosystem. And that requires alignment in what do we want to test, how does the infrastructure have to look like, how is it being utilized, and so forth. In order to help with these aspects, I mentioned IAMTS, and without going into too much detail here, is we are trying to understand how to develop open and closed proving grounds or test beds in an optimal way. And also that this leads to comparability across the globe. And in order to reach this, we have a couple of aspects, and I'm just highlighting here a little bit. So one is we want to facilitate the market introduction of L3, 4, and 5 vehicles through harmonized test methods, test processes, and test beds and test tools for certifications of different regulatory regimes. So we want to help with the mass adoption of autonomous driving at the end of the day. This requires an optimal mix of virtual and physical testing infrastructure. And we also need to define what are the capabilities of those cyber-physical testbeds, so like something like a reference architecture of capabilities for those testbeds, so that we can achieve and measure operational robustness of those CAV complete systems and subsystems. And we also want to make sure that we have testbeds that can handle mixed CAV fleets and traffic flow in different ODDs. And then because we are dealing with different world regions, we have different driving behaviors and different interaction patterns between robotic drivers and human drivers, and that all has to be worked out. So the steps is that first we establish a platform of common understanding of the regional specifics of driving behavior, regulation, and certification practices. We are working on a database basically that covers all the different cyber-physical testbeds that we think are relevant, so that we can offer testbeds to users or make at least recommendations so that they know these testbeds will support standardized test scenarios and we can actually compare results. And then we're also thinking about a certification scheme for testbeds that something like a quality stamp, so that if you use such a testbed, you know what you get and the data is being accepted. What is the recommended path for the ecosystem? And I found a quite interesting paper from the Swiss Re-Institute that was recently published, and I wanted just to share a few things here. They identified 5 forces that will be very relevant for the future of autonomous driving. So obviously the technology development of the vehicles themselves, which I mentioned before, the physical and digital infrastructure, which I highlighted it, the need for increased collaboration between OEMs and tech companies, which hopefully would then bring some of this extreme fragmentation out of the ecosystem and the landscape. We need regulatory developments and then ultimately also acceptance by the customer, which then leads to high adoption rates of autonomous driving. So in conclusion, I think we can say that the regulators need to take a more proactive approach to engage in the development of standardized test procedures and test infrastructure. So they can count on certain organizations like what I mentioned, IMTS, that could help them on this in this effort, so that we have ultimately a framework that leads to compatible and interoperable driving systems that can handle a lot of the real world driving situations. And then there will always be gaps, but hopefully through technology advances and regulatory advances, we can make these gaps smaller and smaller over time. Another important point is that the ecosystem needs to learn to share the use of certified cyber-physical test infrastructure. Not everybody can have his own proving ground. That would be too expensive. And also to share these infrastructures so that we get to a better system interoperability. And that can actually be encouraged by the regulators. And then another important message for me is not to just focus on L4 certification, or let's say L3 to L5 certification, but in particular L4 certification on the vehicle side, but also to include the infrastructure side and then to certify end to end. So with this, I stop sharing my slide and open for questions.
Very good. Thank you, Joachim. We've got some got some good questions for you.
Mm-hmm.
Let's get those up here so we can take a look at them.
Mm-hmm.
Now you mentioned the collaboration of testing facilities.
Mm-hmm.
Now, and you mentioned the M-City program, but there's also another one in near Ann Arbor, is the American Center for Mobility.
Yes.
That also has its is opened testing for between different manufacturers.
Yes.
I know that Toyota has one of their programs is in they have
Mm-hmm.
their own testing facility, and I'm sure the other manufacturers do as well. And I think it just has to do with the privacy that they're looking for in this R&D culture that they're in right now. The M-City program came out with a new testing program, and I don't know if it's a testing and certification or just a testing program in called the ABC testing program. I think it just came out in June. Are you familiar with that?
I have heard about it, but I don't want to speak now on behalf of M-City. But in general, what I can say is just to kind of give you an idea, M-City, in my observation, is more focused on research and collaborative research between OEMs and suppliers. Whereas the American Center of Mobility, to my knowledge, can go further than research. So they can actually help in that certification path that I mentioned. And I think they are working with, I think they are even operated by a test company that is in that certification business. So my point is not so much whether to highlight a specific proving ground or a test bed here. I just wanted to say the interoperability for the mixed fleet that we have on the road requires a shared environment where that can be tested. So that has nothing to do with privacy. So of course we can, an OEM may have tests with a vehicle that is still far away from the market and they want to have the private, totally understandable. But once the vehicle has to go to the market and needs to be interoperable with other vehicles, it's much easier if the OEMs are sharing the test sites. They could even say, here's a fleet. There's nothing private about the shape or something. It's just simply we want to figure out whether we can whether we can be interoperable. Now, it may be very difficult for one OEM to go to another OEM and say, let's test together. It could be also that the regulator says he wants to see these tests. So that was my point, that we need to start thinking about the shared use of test beds. That could even be shared use of highways. I mean, you can turn a highway into a test bed in an open test bed, and that could be then shared by multiple OEMs, just as an example.
Yeah, one of the questions that came up was related to that. Is there anything being done to incentivize this type of collaboration that you were talking about?
Well, that depends on from which angle. So I would, yes, it's incentivized on the research side because there are government grants that would support collaborative research. Incentivizing, and then I would say every OEM and every supplier, but also smaller companies, they are under cost pressure. So so the incentive is to save money, right? So if you do this resource sharing, so you could actually test for lower cost. That's another incentive. And then the third is if the regulator gives you maybe an acceleration of the certification process, if you're willing to do share testing, but that's up to the regulator. I'm not aware that that is currently being discussed, but that could be a topic to be discussed with the regulator.
Yeah. Very good. you've been looking at the different government regulations that are out there right now, and the different processes that they're using. And when you look at the regulators and the regulations, what are the ones that are most needed to build consumer confidence?
So in order to build consumer confidence, so the first thing that comes to mind, if I'm currently using a robotaxi in a pilot, the first thing that the operator will tell me, there's a safety driver in it, right? So but that increases the cost, because now I have to pay a safety driver to be in the car, when I actually, from a business case perspective, don't want to have a driver in the car. So there's a very interesting regulation that has been released this year in Germany, which is, they call it the first law of autonomous driving in Germany, where you are, as an OEM, can, not as a pilot, actually as a regular service, can offer robotaxi fleet operation with telemonitoring. So that means that you have not the safety driver in the car, but it only works in a designated ODD, so operational design domain. So I think if, and that is not that, now you have the legislator supporting this, the OEMs can offer that service to customers. And if the customers would then over time realize, wow, this works and I don't have any problems, then there may be a higher customer adaptation to that, or adoption to this, because then now they have less fear, they think this works. So that is one example what could happen, because I also had some discussions in Germany with a group that worked on a low-speed autonomous shuttle. That was a small town that started that service with a shuttle. At the beginning, it was more like a marketing event, and in the meantime, people got used to it and lost the fear and think it's a useful tool. So even the customer takes time first to get used to it, to understand it, and then the trust is coming. If there are, and that's what I mentioned before in the slide deck with the setbacks, you need to be very sure that there are not catastrophic setbacks that completely destroy the trust. So it needs to, it's very, very important. And for that, we need to be working in a regulatory framework with the right standards in place and with the right check and balance system, so that these setbacks are being minimized.
And that's a good point about of course, building trust. It's in different ways of doing that. Robert's probably going to be talking about some of the issues that that manufacturers are doing as a way of building trust, which has to do with this kind of focused on supporting ADAS systems. Before you get to pure autonomy, you have these other systems that are going to be part of autonomy, that as you get used to them and as you drive with them, and as more of those ADAS systems become are penetrated into the system and into vehicles over a period of time, people will build their own trust within those type of technologies.
Yeah, and I had a personal situation that was a few years back, I think maybe 2 years back, when I was in south of, I think it was south of France, where I was driving with a rental car, which had an ADS system, but it didn't behave like advertised. So, and that then you basically are being stressed, although you thought the ADS is actually making the driving task easier, but now there's a strange behavior and it causes stress, and then you don't trust the system.
Right.
So I had such a personal experience, and I'm sure many others had them too. So that means that you need to make sure that, I think the key question is, are you telling the customer he's completely, he doesn't have to do anything, and only if the system tells him it cannot operate, then it takes over? Or is there more collaboration? And then the other aspect that I think is important is, there had been two groups of companies. The one I would call the disruptors, that basically say, well, we don't go through this period of L2, 3, we are just immediately go to L4, but we're still waiting for these systems to be mass adopted. You know, I mean, yes, there are pilots.
Right.
And then there are the other ones that are saying, well, we do this in an evolutionary step-by-step incremental way. And it looks to me at the moment that this group that does it in an incremental way is gaining momentum versus the disruptors.
Yeah.
So that's at least a perception.
Right. I think that you're right, just because the proliferation of ADAS systems that are on the road today are from the traditional manufacturers.
Yeah.
So they can't implement these and get them on the road so people can actually play around with them and
there was,
hopefully trust them.
Yeah, and I have seen a study that was interesting. They said that the majority of these $100 billion actually went to newcomers, to companies that are not traditionally in that field. And a lot of the OEMs and traditional suppliers use their own money to develop these systems. So there's a distinction to that. And I would say, if I'm a company, we heard before with the LiDAR companies getting $1 billion plus valuations, and an investor gives me money and says, I give you $1 billion or several $1 billion. Well, don't tell the investors that it takes 20 years, right? So they have to make commitments that it may be 5 years. The problem is, as I mentioned before, in a serious way, this AI maybe started 10 years ago, maybe then massively 5-6 years ago. But now is a time where the investors say, well, where are we?
Right.
Why is this not yet on the road?
Right.
And I had personally discussions with some investors where I asked them, well, have you analyzed the regulatory landscape? You made a big decision to invest in this company, but did you talk to the regulators? And they haven't. And that was for me confusing, right? So as an investor, you need to look at the full picture.
Right. Robert, have you guys been looking at the regulatory landscape for your technologies?
Yeah, I mean, of course, that the regulations is a very key point. And yes, Joachim's talk really is actually a good setup for my talk that follows. And I fully agree that there's no standard really out there for verifying these systems. I think one of the few sort of metrics that we have maybe to compare different autonomous driving companies is I think the California disengagement numbers, which are published I think every year. But what most people don't know is that it's actually very, very easy to kind of engineer the numbers. For example, you could just do a lot of autonomous highway driving and get a really good looking disengagement rate. Some other companies are using log resim to prove that the system was actually operating fine when there wasn't a disengagement or something like an issue in the field. So the numbers that you see every year are really you have to take them with a grain of salt. So long story short, I think there is a strong need for standardization to really also compare different technologies and actually gain consumer confidence.
Robert, I'm glad you mentioned the disengagement data, because I'm going to be showing it after the break.
And Robert, one quick comment that I got out of dialogue with regulators and regulatory authorities is that very often they say the OEMs are very passive, right? So they basically listen. They are always afraid that there's a regulation that comes that could harm them or it could be costly. What we are seeing in IMTS is that we have these discussions in a more, there's more freedom in looking at different options, and then actually go to the regulators in a very constructive way to say, look, this would help the OEMs, but it also would help the regulator. Very often in these working teams or working groups that directly talk to the regulator, there might be some hesitance from the OEMs. And as you said, with this disengagement statistics, of course, everybody doesn't want to look bad. So there was this perception, the more disengagements, the worse, but it's actually not true. It could be just the opposite, that you're fixing the system and you need more disengagements. And therefore, I think it is very important to have good preparation discussions before there are these hard decisions being made.
Yeah, totally agree.
Tom, did you have anything you wanted to add?
Yeah, thank you. It's a really interesting talk. Particularly, I was really interested in your mentioning the rental car you had that kind of made you lose trust in an autonomous system. I mean, so from some of our conversations with OEMs, anything that's kind of any autonomous feature which kind of sits between the car and their connection to, ultimately the driver of that car, they're very protective of and seem quite, nervous about. I think in an autonomous future, that's kind of what the feel of driving a car will be like. It will be determined by how their autonomous features work. And, I know anecdotally from lots of friends and colleagues and from driving rental cars, a lot of sort of, in theory, similar features feel very different in different vehicles, and it's kind of part of the connection that consumers have with the OEMs. So I can kind of see the sort of maybe slight reluctance or nervousness around some sort of standardization, which means that they end up sharing any information which could control that. I guess my question off the back of that is: do you think this is something which can be largely self-regulated by the industry, or do you think it's going to need quite strict legislation, ultimately, kind of like, I don't know, emission standards or something, in order to really enforce it?
I think it is important to have that dialogue. So to give you an idea, what you just said, my perception is, if I'm talking now about L4, so it's not about driving assistance or really full self-driving in the pure sense. So I think if I'm making a decision as a driver of the car, I want to sleep, push a button, and I want now to sleep. There should be no difference in principle on the safety side, at least between the OEMs. They should say, well, we need to standardize that this is done in a safe way. There may be differences, and the one OEM says, well, I have a very smooth ride during that, which is maybe smoother than another OEM, and they have to invest more effort to do that. That could be then a differentiator, but we need to have common ground. Number one, between the OEMs, what do we want to standardize? And then with the regulator, how far do we go? And how do we certify this and validate it and so forth? And I think that's where, at least we're trying at IMTS to bring these different parties together. It seems to work because we see that we get more and more members, and we have more discussions in this direction. And it seems to be welcomed by the regulator, because if we give them then a white paper or basically an input, it's already much further than they would usually get in their work group discussions. And so that accelerates the process. And so that's what we see, at least in our interaction. I think that's where there could be benefit. But of course, every OEM needs to protect their specifics and their USPs, right?
Very good. Thank you very much, Joaquin. I want to give you some recent research that we've been gathering from China. These are my Chinese students who are able to read Chinese and decipher what's going on in China. So let's take a look at those slides. Let's look at some of the companies, and one of the things I noticed with Tom when he was giving his presentation was that there were a number of LiDAR companies that I had never heard of before. So it seems like every time I open up a paper to see what's going on in a technology, especially in terms of these autonomous vehicle technologies, there are new companies. So this also applies to what's going on in China. Remember that the Guidehouse information that I was showing you didn't have Pony AI in there. I don't know if they even had WeRide, and they didn't have Didi. So they're companies who are, I think they may have been trying to focus on development, but Pony is definitely working on development, and WeRide is as well. and Didi not so much. They're using other companies to do their technology development. But this kind of gives you that story, and this gets us to the intervention data that Robert was talking about, where Waymo and Cruise are going much longer before they have interventions. In Cruise's defense, they've been doing a lot in San Francisco, which is a much more challenging environment than probably what Waymo is doing down in Phoenix. But you can see that things drop off a lot, as you can with some of the other companies. One new company that I'd never heard of before, Momenta, Chinese automotive driving startup, raised $500 million from a variety of investors, including Mercedes, and they're then also a strategic cooperation with Toyota to provide the latter its automated HD mapping and updates through vision-based technologies, and Toyota's automated mapping platform in China. Robert may be able to talk about some of this. Their first model is by Ziji, which is jointly developed by SAIC and Alibaba. They're supposed to go on sale in 2022. Another company that I was not familiar with was DeepRoot.ai, Chinese self-driving solution provider offering robo-taxis, and started doing this in just this July. This is in Shenzhen, and they have safety drivers are still required in this particular case. They're capable of recognizing, they say, all kinds of transport participants as far as 100 meters, doing route planning and decision making based on real-time road conditions. Now, a lot of this stuff could be a lot of PR that's just coming out by the companies about all the things that they can do, as opposed to what they're actually doing. They also say they have level 4 self-driving solutions. They're carried out in areas in Shenzhen, Wuhan, and Hangzhou, accumulating over 2 million kilometers in safe testing mileages. Another company, Inceptio, Chinese autonomous trucking startup, focusing on long-haul freight shipping. This is what Waymo is doing with JB Hunt and here in the US. They've reached some jointly with JD Logistics, Meituan, and PAG, Chinese companies. They developed their own system to 2 level 3 heavy-duty trucks, including a startup jointly with Dongfeng, Sinotruk. They're expecting delivery at the end of 2021, and also using over-the-air upgrades. The system will help the trucks advance into level 4 into the future. And then you have Huawei, BAIC, Shangan, and GAC forming a partnership. Huawei forming partnerships with them to roll out self-driving car brands starting at the end of this year. Again, this could be these are PR things, could be PR things as well. We've seen companies who say that they're going to do things and that they don't always do them. For collaboration with BAIC on the ArcFox, Huawei would design the interior of the car, while the car would be manufactured by BAIC. They claim that Huawei's autonomous driving technologies have overtaken Tesla's on some occasions, such as allowing cars to cruise over 1,000 kilometers in downtown areas without human intervention. XPeng, an automotive company in China, is officially began to develop the development of autonomous driving, a chip in the US and in China. It has a R&D group of all of 10 people, and they propose to have their first chip tape out in 2021. Already came up with a high-speed autonomous driving navigation using the NVIDIA chip. But and XPeng's V5, which is going to start delivery in fourth quarter of this year, will also be sold in Norway and EU markets. They argue or suggest that say that they're world's first mass-produced smart EV equipped with automotive LiDAR technology. I'd like to hear Tom's views on this part. They install the 2 LiDAR sensors in the front rather than on the roof in a bid to efficiently reduce air resistance. The LiDAR device is supplied by Livax, a LiDAR technology developer incubated by Chinese drone maker DJI. Now they're using that NPG guided pilot system for their in-house developed AV system, which consists of 32 sensors, including 2 LiDAR units, 12 ultrasonic sensors, 5 millimeter wave radars, and 13 high resolution cameras, and 1 high precision positioning unit, and hopefully an amazing fusion sensor device on the inside, bringing all this stuff together. Honda is doing some work with AutoX, a self-driving developer backed by Alibaba, to explore autonomous driving solutions. Obviously, this is a R&D situation. They're planning to jointly carry out autonomous vehicle tests on public roads using the Accord and Inspire sedans and using AutoX's self-driving technologies. AutoX announced that in its robo-taxi service with no safety drivers behind the steering wheel was available to the general public in Shenzhen. Geely has applied for a patent for an autonomous driving method, system, and vehicle using cooperative vehicle infrastructure system. So here you're looking at the connected vehicle as well as the autonomous system itself. And we haven't talked too much about at this conference about connected vehicles. So I think it's kind of there in the background, but a lot of people can see that the connected vehicle to the infrastructure is as important as the autonomous vehicle technology itself. So Geely is doing a lot of patenting for this. Aon, which is a electric vehicle company from GAC company in China, they have adopted the 2nd generation smart LiDAR, solid state smart LiDAR of RoboSense for its autonomous vehicle driving system. Capable of level 3 autonomous driving functions on highway and urban expressways, much more reasonable sounding compared to the Xpeng story. RoboSense has strategic partnerships with AutoX and bandwidth network technology, smart car operating system and solution provider backed by Alibaba and SAIC to build high-level autonomous driving platform for intelligent vehicles through in-depth cooperation with a 3D LiDAR system. There it is, that 3D LiDAR, Tom. AI algorithm and intelligent automobile operating system, and create an advanced smart cockpit based on human-machine co-driving. And the automated valet parking system co-developed by Baidu and Great Wall, which is expected to be introduced into mass produced model the second half of this year. We've seen the automated valet parking. I think this is something that Valeo showed at the ITS World Congress probably, I'm thinking it's 5-6 years ago at least. So this is something that we've seen before. Mini-Eye, Chinese autonomous driving technology developer, developed Series 1 funding, provides AI-enabled sensing solutions for autonomous vehicles. It's working on customizing ADAS solutions according to clients' demands. And they've teamed up with Dongfeng Motor, Geely Commercial Vehicles, SAIC, BYD, and others within China. And finally, of a robotaxi in Shanghai, Pony AI announced that they are in July that they're doing a pilot operation of robotaxis in Shanghai. It consists of a modified Lexus RX vehicles armed with Pony AI's latest autonomous driving system. So far, Pony AI self-driving trucks have traveled 37,000 kilometers and transport roughly 13,000 tons of goods. So that's the kind of some of the things that we're finding out from China itself about things that are going on there. And with that, we're gonna move on to our next speaker, Robert Zidek. Robert, let me give you a quick bio here. Is a roboticist at the Toyota Research Institute, where he has worked on automated driving technology since 2017. At TRI, he's leading the vehicle behavior and motion planning effort. This includes areas such as behavior prediction, decision-making, and trajectory planning. Robert is focused on building a universal system that supports both level 4 autonomous driving as well as advanced driver assistance systems that amplify the human driver. Received his PhD in aerospace engineering from the U of M. Okay, Robert, take it away.
Thank you, Bruce, and thanks for having me. Maybe I can very quickly comment on what you were presenting to us. I think, as we said before, you really have to take these California disengagement numbers with a grain of salt, because you can really engineer the numbers. I mean, don't get me wrong. I think Cruise and Waymo are certainly at the top right now, but there are a lot of smaller companies that are trying to get venture funding, and they really have to look good on the California disengagement numbers. And there are certain ways to get to reach good numbers there. And interestingly enough, all the companies in the AV industry popping up in China, that's actually very interesting to see. It kind of reminds me a little bit about the US industry maybe 3 or 4 years ago, where we had lots of smaller companies. But eventually, I think they will also notice that you need lots of resources to develop these technologies. And there will probably be more consolidation in the future in China. But yeah, with that, today I will give you some overview of what we are doing at the Toyota Research Institute on the automated driving side. The overview of my talk is, first I will give you some key facts about TRI and Woven Planet, our colleagues at Woven Planet. Then kind of tell you sort of what drives us, what motivates us, and show you our approach to automated driving, which we believe in a one system and two modes approach. The two modes we refer to as chauffeur and guardian, and I'll tell you more about that. Then I'll show you some example AD capabilities. Okay, Toyota Research Institute was originally established in 2016, really with the purpose of developing Toyota's future capabilities. And one key mission is really to amplify humans, not to replace humans. We have about 300 people at TRI. A lot of our R&D staff are PhDs, have PhDs, but you have to be really hands-on and be a good software developers. And don't think that you need a PhD to join TRI. We have lots of really good engineers and researchers that don't have PhDs. At TRI, we have several focus areas. The biggest focus area is automated driving, where I'm working at, but we have other areas that we're researching in robotics, mobile robotics and home robotics, advanced material science, and machine-assisted cognitions are some other areas that we look at TRI. And then we're working very closely with other Toyota companies. And in automated driving, we are really working extremely closely with a company called Woven Planet. They actually just renamed themselves into Woven Planet. They used to be called TRI-AD, TRI Advanced Development. So we've really, in the past year, started to work effectively as one global team between the TRI Automated Driving team and Woven Planet. And as the CEO of Woven Planet is saying recently, after Woven Planet acquired Lyft's autonomous driving division, as well as Camera, who is a mapping company, that now between with Toyota Research Institute, the automated driving part of Toyota Research Institute, the former Lyft autonomous driving division, Camera, and our colleagues at Woven Planet in Japan, we now really have a dream team for automated driving. And in fact, so we're scaling up quite a bit. If you want to join the dream team, you can either join us at TRI or at Woven Planet. And in my team in planning and controls, we currently have some openings. So if you're interested, please reach out to me maybe after this talk or on LinkedIn. Okay, and sort of what's our motivation? What keeps us up at night? So statistics tell us that there are about 42,000 vehicle fatalities each year in the United States. And just to give you a comparison, that's roughly one Boeing 777 crash almost every day, just for the United States. And worldwide, there are more than 1 million annual vehicle fatalities, which is roughly the equivalent of 18 Boeing 777 crashes each day. And that's too much. So that's like a strong driving force for us, is really to reduce vehicle fatalities. One obvious solution would be really large scale deployment of true level 4 mobility as a service systems for everyone and everywhere. But as we already kind of talked about in the previous talks, it's actually much further away than we think. So we are working hard on it too, on level 4 driving, but I think it's still some time out. And as Joachim was saying in this talk, there are several things that really we have to still figure out. Obviously, on the regulation side, every country has maybe no clear guidelines or different regulations. And really to verify and validate the system, how safe is safe enough for a big company like Toyota. There's a lot of liability and brand risk. And just on the technology side, there's still a lot of rare long tail corner cases that can occur that we really have to solve, I think, before we can deploy level 4 in a large scale. But at the same time, humans are actually incredibly good drivers in most cases, or most of the time. So we're really thinking, how can we deploy some of our AI technologies sooner than later and save as many lives as possible as soon as possible? And our key, our strategy is really this developing one system that can support 2 modes that we call the 2 modes, chauffeur and guardian. And I'll tell you more about those 2 modes and on the next slide. And the key principle is to use our AI to guard and amplify the human driver. And then by deploying things sooner, we can learn from the massive fleet data from the Toyota fleet and learn from the human drivers. And here there's an overview of these 2 modes, the chauffeur and guardian mode. So chauffeur is really level 4 driving, fully autonomous driving. There's no driver needed. The car is driving itself at all times. And as we kind of discussed a little bit, it's still maybe a few years out, and who knows if we will ever fully achieve true level 4. But everybody is working on it, and we're working hard on it too. And we'll probably see, we're already seeing some incremental stage commercial releases, likely starting with shared mobility fleets. And the guardian mode is really where the driver is driving the car. The driver is engaged at all times, but we use our AI system to monitor the driver and intervene if there's a dangerous situation and help prevent collisions. So the guardian mode actually shares a lot of the core hardware and software capabilities with our fully autonomous chauffeur system. And that's sort of really highlighted here on this slide. So guardian and chauffeur are really the convergence of ADAS and autonomous driving. And the core technologies, perception, prediction, and planning, are really shared between the two modes, and we're trying to develop one system to support both of these modes. And actually, Joachim brought up a very good point that really current ADAS systems are kind of limited. I've also had similar experiences where a lane keep assist, for example, is actually pushing you towards, let's say, a bicyclist or a car in the adjacent lane because you're reaching the boundary on the other side. So a lot of people find it annoying and confusing and turn off current ADAS systems. So what we're really trying to do with this strategy is develop much better ADAS systems that are more context aware using our AI technology. So effectively, by improving the chauffeur level 4 system, we're improving our guardian mode. And by improving our guardian mode, we're improving our chauffeur mode. So that's really the key principle of this one system, two modes approach that we're pursuing. And let me go into a little bit more detail on each of the two modes. So chauffeur, the true level 4 autonomous driving. I will show you a few examples of our chauffeur system. But first, let me give you a quick overview of our vehicle platforms. So in 2016, when we started out, we had our platform 1 vehicle, and that's maybe quite interesting also related to Tom's talk. You can kind of see the generations a little bit here. And over the years, we converged to a really good sensor and hardware set in our P4 platform 4 vehicles. So the P4 is really our workhorse, where we do all our testing testing is a good keyword, also kind of related to Joachim's talk. We really focus a lot on testing and verifying our systems at TRI. Most of our testing, or we spent a lot of time really doing virtual testing. That's the core block of our testing strategy, using simulations, log replay, and these kinds of things. And then closed course testing, we also touched on this. We test on in our closed course test facilities. We have one in Michigan, close to our office. We also in the past tested at ACM in Michigan, but now that we have our own test track, we test there a lot. And so basically, once we're confident that the software is working well in simulation and in closed course, then we release it for public road testing, where we test in the United States and in Japan. And here's just a brief overview of how we do simulation testing for motion planning. I mean, this is pretty standard. We focus obviously on subsystem testing, where we test the planner only, then the full system, where we test perception and planning and the controller and in the full system mode, as well as hardware in the loop testing. And as I mentioned, closed course testing, we have our own test track very close to our Ann Arbor office in Michigan. You can see it here. This is, I think, from the early days. We added a few things to make it more interesting, more complex. But yeah, you can see it's actually a US portion, which is the bottom side, and a Japanese portion right now, which is the top side. And we test here really a lot every day. And we can also use, there's an oval around it that we can use for, higher speed testing as well. And then we do, like I mentioned, we do a lot of public road testing as well. We do daily autonomous driving in the United States and in Japan with our P4 fleet. We actually do a lot of driving in Japan, but also in Michigan and in California here in the United States. Okay, let's see if I can reach. Okay, and this is just some a small overview of what I do with my team on the vehicle behavior and motion planning side. So our key development goals, or top priority is safety, to guarantee safety at all times. And then the second priority is to achieve a human-like driving behavior, to really, which is very important for the human or passenger to gain confidence in the vehicle. And we've made very good progress on that side. So I think in more than 99% of the cases, more than 99% of the time, you cannot really tell if a human or autonomy is driving our car. So I just recently took a test drive, and it's really quite amazing the progress that we've made on that front. And the approach that we're using, first of all, we're trying to develop a modular software so that we can support both, robo-taxi fleets, mobility as a service, as well as personally owned vehicles. And we've developed a multi-hypothesis decision-making system where we incorporate lots of ML for the decision-making and prediction side, lots of machine learning. And on the trajectory generation side, we use an optimization-based approach for where we can get verifiable guarantees on safety, as well as also ride comfort and smoothness. And here you can just see a few examples of what we have to deal with daily. Of course, pedestrian handling, sharing a crosswalk, avoiding randomly parked cars, the parked cars that are randomly parked in the middle of the road. In Japan, the streets or the lanes are actually quite narrow compared to the United States. So narrow lanes and dense urban traffic. And on the bottom right, there's also an example, handling road construction immediately followed by a double lane change to make it into a driveway. So yeah, with that, I want to talk a little bit about our Guardian mode now. As I mentioned, that we share, Guardian and Chauffeur share a lot of the core capabilities. One key addition that we need to enable Guardian and really bring the human into the picture is what we call this blended envelope control technology. And this is really inspired by modern fighter jets or modern airplanes where the pilot is operating the airplane with the stick, but the pilot is not actually controlling the actuators, like the control surface. The pilot is engaging with the lower level control system that really ensures that the airplane is staying within a safe, dynamically feasible operating regime at all times. And we're trying to do the same thing for cars, but for cars, it's actually much more difficult than for aircraft because there's a lot more uncertainty. So there are infinitely many different road geometries and so on. There are, of course, the other agents like pedestrians, bicyclists, and other vehicles that really bring in a lot of uncertainty, which makes it very challenging to estimate the safe operating regime. And you can kind of get an idea about how this works in a car on the bottom right, where you see the green carpet is the safe operating envelope that the system estimates based on the perception of the surroundings. And then you can kind of see that the driver in this case is trying to crash into some of the cones, but the system is not letting the driver crash into the cones and keeps the car in the safe operating regime. And the way we test the system is by adding another steering wheel into the car. So we have a replicated set of steering wheel and pedals, which we call a dual cockpit, where the driver can drive the car via steer-by-wire, which allows us to blend the inputs of the human and the AI system. And there's, for testing purposes, still a safety driver that can always disengage the entire system in case we reach an unsafe state. And here are two examples of our Guardian system in action. On the left side, we kind of recreated a scenario where a vehicle pops out of an occluded driveway. So we really made it such that an average driver would not be able to react to it and cannot avoid a crash. And you can see that our Guardian system has to decide, all right, do I stop for this vehicle popping out, or do I nudge around it? And in this case, in combination with what the driver wants to do, the Guardian system is helping the driver to prevent hitting this pop-out vehicle and safely making it around it. And on the right side, you see another application where we set up a slalom course and put a driver in the vehicle and told the driver, try to go as fast as you can through the slalom course. And I tried it myself several times, and it's really difficult. Most drivers don't make it through the slalom course without clipping a cone. And you can see, and we let them drive through it without Guardian engaged. So here you can see that, especially as you reach throughout the end of it, the vehicle is kind of already near instability. Most drivers are clipping a cone without Guardian, our Guardian system enabled. But then we switch on Guardian, and it's extremely amazing. You don't really notice the Guardian system helping you, but you can go as fast as you can, and you don't clip a cone, and you really feel like you're the best driver out there. And that's I've experienced it myself, and it's really kind of amazing how with like a tiny addition of control input to your own human input, you're making it through this slalom without clipping a cone. And it's a lot of fun to drive like that with the Guardian system enabled. Okay, let me wrap things up with our third pillar, fleet learning. So this is one of Toyota's biggest advantages in developing these new autonomous driving technologies, because Toyota has the biggest fleet out there. So we're selling the most vehicles, about 10 million vehicles each year. And with this large fleet, we believe that we can really accelerate our core autonomous driving capabilities. And this final slide shows you kind of how we're intending to do it. So we have our one system, two modes, and we can incrementally deploy parts of it once these parts are mature, and once we're confident that we've validated them enough and that they're safe, we can deploy them in various Toyota products, Toyota Safety Sense, Toyota Teammate, or in the future mobility as a service systems. So by deploying parts of our AI technologies, we can learn from human drivers and haul back the vast amount of data, and with smart sampling and scenario detection, we can use that to improve our core AD capabilities on the perception, prediction, and planning side. And as you mentioned, Bruce, also on the mapping side, so this automated mapping platform is really about building a global map from fleet data that is really the underlying technology to support these core capabilities and this one system, two modes approach. Yeah, with that, I think I'm happy to take questions. Thank you.
Very good. Thank you, Robert. Let's quit sharing your screen. I think you have to go to the top to stop sharing.
Yep. Here we go.
There you go. There you go. Very good. And we have our fourth speaker with us, Mircea Gradu. Mircea, welcome.
Thank you. Good morning and good afternoon.
Yes, very good. We're in the Q&A session now. Robert, we've got some good questions for you. I wanted to start out with the story of the driver always being engaged. It's different from what some of the other companies are doing, right? Where they're trying to tell you you can disengage. and that you don't have to drive as much. But then if something happens, you're going to have to come back. You're going to have to come back and start and re-engage. And my colleagues in the Human Factors Division over at the U of M Transportation Research Institute have been pulling their hair out for years over this. And the testing that they have done about how long it takes for someone to re-engage after they've been disengaged, it's scary. And it sounds like you guys have been seeing that as well, which is one of the reasons that you're saying you need to be engaged. You need to be driving. We're going to make you a better driver, but you're going to have to drive. Is this kind of your reasoning?
Yeah, I think that's a very good point. And you can maybe compare it with Tesla, where you really need a human to watch the autonomous system, right? Whereas our approach is exactly the opposite, where we want the autonomous system, AI, watch or guard the human. So I think that's a fundamentally better approach, because it's really the safer way, in my view, to deploy these technologies.
One of the things that when I was looking at the different things that you were using in the different system, Guardian system in particular, is can you talk about some of the things that you are working on that are related to that? Because I think it was when you look at it's like motion planning and things like that. When you're using that kind of system, it looks like a lot of the things that you're working on are directly related to that.
Yeah, that's true. So, like I said, we're building one system that can support both the chauffeur mode and the Guardian mode. And in the chauffeur mode, what we really need to compute or generate is trajectories that can be exactly tracked by a lower level controller. So that's the responsibility of the motion planning team for chauffeur. For Guardian, it's a little bit different. For Guardian, we really have to, instead of estimating trajectories, we have to estimate sort of the safe set or the safe operating regime. So if the human stays within the safe bounds, the human and the car is safe. So that's kind of the difference between Guardian and chauffeur on the side, what my team is looking into. And as I mentioned, compared to modern fighter jets, where you also have the safe operating envelope, it's much more difficult to estimate it for vehicles, because there are other agents in the scene that really add a lot of uncertainty into this. Pedestrians, bicycles, and other cars, as well as the road geometries. Like I mentioned, there's basically infinitely many road geometries that you have to handle. So it's much more difficult to do this than for aircraft.
One of the attendees asked this question: what do you believe is the single most difficult real-world driving scenario to try to navigate with AI?
I think the most difficult, or like one of the most difficult problems is really dealing with pedestrians and bicyclists, because it's for vehicles, for other cars, you usually know kind of they're following this lane or they're following this direction. But pedestrians can add a lot of uncertainty. So it's extremely difficult to estimate the intent of a pedestrian. The pedestrian wants to cross or wait or keep walking this way or that way. So I think that's one of the most difficult problems, I would say.
Yeah. What role are the automotive suppliers playing in your AV technology development?
So we work very closely with other teams, especially on the hardware side, other teams in Toyota, to build our vehicle platform, and we work with other suppliers as well. Toyota has its own suppliers for hardware sensors, and so on, as well as other companies. So we work a lot with suppliers for our vehicle platform and hardware.
Are these your traditional suppliers that you use for your regular gas vehicles?
Yeah, yes and no. Both. We work with both sides, I would say.
Yeah. Okay. Now, when I was looking at your the story that you were showing about how vehicles maneuver in different situations, I said to me it was reminiscent of Google Maps, where companies would hire people around the world to identify all the objects on the roads in order to teach through AI for automated vehicles. Is your group involved in any of this research?
You mean on the mapping side of things, or
Yeah.
learning from so yeah, we obviously, it's very important to have a good underlying map for motion planning and prediction and so on. So yeah, we're closely working with our mapping team, and like I mentioned, this automated mapping platform is this effort to really map the world and have the most updated map coming and based on fleet data.
Yeah, that's one of the things that we've seen. Well, your colleague Ryan Eustace, who presented at our conference in the past, that he had been working on, where you were trying to use kind of like 3D mapping to be able to identify everything in an area. Obviously, it becomes a problem when you're trying to identify when you're driving in an area that doesn't have those maps. And then you're just relying on the sensors, right, to be able to make a decision. Again, this is chauffeur mode, right, where where the vehicle is driving itself, so that the need, it's hard to map the world. Right?
Yeah,
you know?
No, you need a lot of data, that's for sure, and it's actually, quite frankly, not different between chauffeur mode, like level 4 driving, and this Guardian ADAS systems. You really need a good map in both modes or both systems.
Yeah. Well, when I listened to the story about the way that you guys are working on the Guardian mode and the chauffeur mode, it's very interesting as a traditional automotive manufacturer that the company is saying, we want you to keep driving. We want to make you just a better driver for as long as you possibly want to. And later on, as we develop the chauffeur mode, eventually you'll be able to not drive if you don't want to. So it looks like the company is kind of envisioning a world in which there are a combination of autonomous vehicles and semi-autonomous vehicles. Do you think that's an accurate description?
Yeah, I think that's a very good description. So we don't want to replace the human driver. I mean, we still believe that the human driver, if the human driver chooses to drive the car and wants to drive, it should be able to and enjoy driving, in fact. And I think what maybe Joachim or Tom was saying, that, I mean, the other option is the driver could push a button and go to sleep and wake up at a destination. So we really want to provide both options to the driver. And then on top of it, there will also be shared mobility fleets where you maybe have shuttles operating autonomously in level 4, kind of what Uber and Lyft is doing. That's another story, but that we're also working on that, of course. But for personally owned vehicles, I think the driver should have the choice by pushing a button to go into fully autonomous mode, or the driver wants to drive the car, the driver should be able to, and then our Guardian system would watch the driver and prevent collisions.
And it allows you to be all in or all out.
Correct.
Right?
Yeah.
So there's none of this in between stuff where you have to, oh, by the way, you have to catch on. You have to re-engage. I know you were not paying attention for the last 15 minutes, but right now you have to get re-engaged and look around and find out what's going on. I think it's a smart move for the company in terms of making the driver still be part of the solution rather than having them check out until you actually need the chauffeur mode or want the chauffeur mode, that you actually have this option. Yeah, especially in the long-term planning, with the way we're looking at the development being so much farther in the future for the more advanced AV systems. Let's start with you, Tom. Did you have anything that you wanted to add to the discussion on this?
So I guess one of the things that kind of struck me, I mean, it's a great talk. The Guardian mode looks really fun. How kind of related to the hardware platform are the results of your research? So, you know, if you clearly have quite a lot of sensors on the vehicle, probably more than you'd likely implement in a passenger vehicle. So, you know, how easy would it be to port onto a more, you know, conventional serial production vehicle? So how far away is it from being available in a car I could buy?
Yeah, that's a very good question. So obviously, in our research fleets, we have the best sensors, but we're working really on a system that can support also personally on vehicles where you have you know, not the best sensors, maybe because, as you were saying, cost is a very important factor. So then we have to be able kind of to dial the system, you know, dial down maybe the LiDAR knob or the sensor quality, and still be able to provide good functionality. And that's kind of a key focus of our team here at TRI and Woven Planet, to develop a system that can really support, you know, the high-end robo taxis with the best sensors, as well as personally on vehicles where you may have different sensors. And yeah, it's still you know, an ongoing development, but we like I mentioned, we want to incrementally deploy parts of our system in products, and that's coming really soon.
Joaquim, did you have anything you wanted to add?
Yeah, I had basically maybe two comments. The one is I saw that Robert was segmenting public road testing, proving ground testing, and simulation. And I think in the public road testing, I have been using in my presentation the term open test bed. And that's a little bit a hybrid. So that means that you are testing on public roads, but it could be more monitored or it could be configured. So that is a missing piece in the classification from my perspective. Maybe I'm happy to discuss this further offline. And then the other topic is the data sharing of digital maps. Because I had some discussions with people that are making digital maps, and there's some potential thought is to create digital maps that are shared between multiple OEMs. Because again, it is always, in my opinion, the key thing is how much is the development cost, and is it worth to go alone? You can do it, of course, if you have critical mass. And Toyota is a very big company, have a lot of resources, but even big companies are sometimes limited in their resources. So that's another thing to think about, sharing or shared approach, just as a suggestion.
Yeah, I think that's a good point. I mean, I can't comment exactly about sort of the strategy for the automated mapping platform, but in general, you're right. I mean, the more data you can get, the more the better the map will be, and so on. So that's why I think a shared approach makes sense, and also providing technology to other OEMs, other companies, does make a lot of sense. Maybe also from a commercial point of view. Yeah, and I didn't quite get your first point though.
With the open test, but yeah, what I meant with that is, for example, on public roads, there's two approaches, I would say. The one is I'm driving randomly on a road and encounter a certain situation. So let's say you tell a test driver drive from Detroit to Indianapolis, but you don't give him any restrictions how he drives. And then the other would be you tell him exactly what the route is, and you're repeating this over and over. And these are for me two different cases. Yeah.
I see.
Yeah.
And you're talking specifically about the Guardian testing, or more about
no,
level
it could
4?
be either way. So for example, let's say I'm selecting a specific route from A to B, where I know a lot of these scenarios that are relevant for you or for customers are being covered. Then you would standardize these routes for you. It could be just inside of your company. You can say, okay, I'm driving this over and over, and I can compare versus just randomly driving around and finding situations.
I see. Yeah.
So that is something I would distinguish.
Yeah. We do distinguish between the two as well.
Yeah. Okay, that's fine.
Very good. Mircea, you came in a little later in the middle of the presentation. I don't know if you have anything you want to question or add to the discussion.
Well, first of all, yeah, great presentation by Robert. Parts of it, I should know it because we worked with TRI over time, and we are one of the partner companies that you referenced before, Bruce. That's a great ecosystem they have on the vehicle, and we were very, very happy to be part of that. My question or comment is similar to Joachim's. It relates to crowdsourcing and optimal vehicle trajectory based on this kind of repetitive pattern that you can identify. And I was just also wondering if that becomes an area of interest for TRI and for Robert in his research, namely to try to optimize the trajectory of the vehicle based on that type of information that you collect by vehicles and people driving over and over this repetitive path, and trying to implement that then into the vehicle control, certainly because obvious reasons. So
yeah, that's a very good point, and that's really our strategy here with fleet learning, to learn from human drivers, the massive Toyota fleet, and improve our systems, especially on the vehicle behavior and the decision-making side, but also on the trajectory optimization side, to learn parameters from human drivers, and on the decision-making and prediction side, to really learn from the ground truth that you observe, and that's a very important part of our strategy of deploying things globally and then learning from the human driver.
Very good. Thank you, Robert. Before we get into our next speaker, I wanted to remind the audience that all the speakers are available to speak with through our Meet the Speaker program. That is the link to sign up for that is in the email that I sent you yesterday, but also underneath the YouTube video that you're watching right now, there's a link to that program for signing up if you want to meet with any of the speakers after the conference. So they've all agreed to hang out for a half an hour and do 2 people each, 15 minutes each. And if anyone wants to talk with the speakers, feel free to sign up. Okay, our last speaker of the day is Mircea Gradu. Let me do a little intro for you here. He's the Senior Vice President of Automotive Programs at Velodyne LiDAR. Started his career at Daimler-Benz AG in Stuttgart, Germany, and prior to Velodyne LiDAR, he was head of engineering and quality at Hyundai Motor America. His past experience includes top executive positions as Vice President of Transmission, Powertrain, and Driveline at Fiat Chrysler, and Head of Automotive Engineering at the Timken Company. Mircea holds a master's degree in mechanical engineering from the Polytechnic Institute of Bucharest and a doctorate in mechanical engineering from the University of Stuttgart in Germany. Welcome, Mircea.
Thank you. So I assume I can share my screen, perhaps?
You can share your screen.
Wonderful. Great. Okay, so good morning, good afternoon, everybody. Thanks for attending this great event. Thanks, Bruce, for organizing along with the team at the University of Michigan. The topic of my presentation will be very much aligned with what I caught Robert commenting on, which is pedestrians and in general vulnerable road users, which includes motorcyclists and cyclists, bicyclists. So that is definitely an area of focus, and that's why I kind of centered my presentation and talk around this topic. There are literally emerging sciences like functional safety and SOTIF, which some people don't understand in terms of the acronym significance, but that is the safety of intended functionality. I think that's, again, one of the emerging sciences, and it's worth talking a little bit about it in this context. I certainly need to introduce quickly my company. I'm very proud of being part of Velodyne LiDAR because we are one of the pioneers in automated driving, and certainly in the LiDAR use for automated driving. I will talk about the ADAS LiDAR-centric hardware and software solutions that we developed. A little bit on our safety initiative, the pedestrian automated emergency braking, so a very focused AEB solution that we developed, and its validation. And then I was planning to focus on some of the gaps in the current legislation and in the validation protocols related to ADAS, and perhaps specifically related to PAEB. First of all, in case LiDAR represents a relatively new technology for some people, you know, in the audience, I just wanted to show this quickly. On the left side, you see a so-called point cloud generated by a LiDAR. So it's an image, a 3D image actually. And what's really important to understand is every single point in this image has a 3D distance XYZ information associated with it, which shortens the compute time relatively to the frame-to-frame approach for cameras. So the LiDAR has this inherent advantage of providing also all the distance to target information to the time of flight approach, photons flying and hitting the target and coming back. So a laser beam essentially used for that. The other advantage of LiDAR in certain applications is certainly the privacy aspect. It does preserve privacy, and that's a major requirement by essentially all legislation around the world currently. We started very early, relatively to other newcomers to this space. There are a lot of them, but we started in 1983 and gradually moved from a different area, acoustics, into applying some of the common principles to LiDAR technology, the 3D LiDAR technology. And essentially more than 15 years ago, we were competing in the DARPA challenge with instrumentation on the vehicle and a sensor suite that was at the time, again, pioneering the LiDAR technology for autonomous driving. And I think another milestone is certainly the 2007. You see there the kind of the landmark in the in autonomous driving that bucket-shaped LiDAR, the HDL64, and again, that was one of the major introductions in LiDAR technology or breakthroughs. We are represented around the world, and I think that's very important because we understand, similarly to Toyota and any other manufacturer, the various requirements and specific driving conditions and traffic conditions around the world, including certainly China, including Europe, including Korea, India, and for sure the US space, the North American space. And that's, again, very important, both from the development and manufacturing perspective to leverage various capabilities. I'm running quickly, but certainly any questions we can address them at the very end. The sensor offering that we have currently available includes the surround sensors, 360-degree horizontal field of view, which are very important in autonomous vehicles, especially the level 4 and 5. And you can see them on the left side with the flagship of our product called Alpha Prime, 128 channel and 300-meter range LiDAR. And then on the right side, you see the latest developments in solid state and directional sensors, including the H800, M1600, and the Velabit, which is now at its second design iteration with a wider field of view and enhanced performance. So that's the very right side of the screen, and that is an embeddable sensor that is extremely suitable along with the H800 and M1600 for ADAS applications, where the priority of having a very well integrated device within the vehicle styling, light, not affecting negatively the aerodynamics of the vehicle, essentially addressing, if you want, the energy efficiency aspect as well, because we're operating on electric vehicle as we know, or plan to in the future. So we don't want to affect that energy efficiency balance negatively. We actually want to be very well aligned part of that. The automotive space with ADAS and AV is just one of the many industries and areas where LiDAR technology is currently applied. I guess that's just interesting for general knowledge, but it spans over certainly also other traffic optimization related topics like smart cities. You see a LiDAR on a pole in an intersection, again, optimizing traffic from the emissions, energy efficiency perspective, minimizing certainly bottlenecks and traffic jams. But there are many, many others in the aerospace and drone area. There are applications in the so-called automated mobile robots. And with COVID-19, that became a very interesting space, especially for hospitals and other medical facilities, warehouses, and so on. So very, very broad area of application. The directional LiDAR that I mentioned, and in particular the H800, which I'm showing now on the screen, is one of the products that we plan to deploy in mass production, and therefore we developed a very efficient architecture using this micro LiDAR array, and that's common between various LiDAR platforms, and that allows us, again, a very cost-effective and modular approach that supports, again, automotive applications. Also, the Alpha Prime for autonomous vehicles, similar to the Lexus vehicle that was shown by shown in the previous presentation. I think the idea here is, again, to perhaps focus truly on the long-range requirements, broadest possible horizontal field of view, 360, and complementing that sensor with others on the sensor suite that minimize the blind spots around the vehicle. And all that certainly done with meeting all the automotive grade requirements, which certainly is a significant challenge for the whole industry. And coming back to the Velabit, which I briefly talked about, this is more detailed information on the size and capability of the sensor. So it's truly impressive in terms of the capability for, again, seamless integration in the vehicle styling. And then you can see the range and horizontal vertical field of view are extremely suitable for ADAS applications as the sensor was intended. We complement all that with software developed specifically for ADAS. That is our Vela software, including obstacle detection and tracking. We provide the object recognition based on the LiDAR point cloud that I showed before. So that LiDAR point cloud, given its level of, if you want, detail, allows for object recognition and classification segmentation based on only on the LiDAR input. And that applies to static and dynamic objects. Certainly we do the motion prediction and collision mitigation based on the ego motion and the motion of the target that we are monitoring, and feature harvesting and automated HD mapping, as we discussed before, very important aspect, localization. And we provide that data also for upload, or can provide that data for uploading and remote polling. And that's another interesting model there. On our safety initiative, it becomes really interesting now on how these things are all applied, and also, if you want, our interaction with the community around the safety topics. So we have a very significant advocacy, outreach initiative, and that includes certainly the Hill in DC, the Department of Transportation, NTSB, NHTSA, and the goal of all this is, again, actually safety is the goal of everything what we are doing, and I think it culminates with trying to educate our policymakers and certainly all the organizations that are involved with legislation and regulations in this space, educate them on the technology progress, and also on the, as I said earlier, on the potential gaps that are existing currently in the validation and, if you want, testing of those vehicles. If we focus specifically on the automated emergency braking, and we included here also the automatic emergency steering, you can actually create a generic rating system, and that's what we proposed to various organizations, including SA International. And this approach is, again, an attempt to actually assess and do this in a kind of technology agnostic manner, assess the capability of the vehicle, independently of what ingredients you have in the sensor suite. If you're using LiDAR or not, that's, in this context, less important. What's important is what is the vehicle behavior under those conditions relatively to, and how that impacts safety ultimately. So you can see that we have this 5-diamond rating system, which is very similar to the other crash worthiness related system, if you want, currently applied in vehicles. And you see the various categories like maximum speed detection reliability, pedestrian, bicycle, motorcycle detection and classification range. Those are the criteria that at the vehicle level are being used to assess one or another system on the vehicle. So that's what we proposed. And This relates to the earlier comment that I made, SOTIF, safety of intended functionality. No matter if that whole sensor suite or the entire stack on the vehicle performs as intended, flawlessly, again, without any potential failure or defects, is that satisfying the required safety in that operating condition? So obviously that certainly highlights a lot of the limitations of the technology, and not faulting that specific technology. That technology is one of the components that makes everything working well in concert, but perhaps is not sufficient. So you have to add something else on the vehicle to ultimately achieve the safety that you want at the vehicle level. So this is not about identifying defects, or it's not the usual design failure modes effects analysis, but it's something significantly more important, which is the end goal, to maintain the vehicle safety. We proposed a rating for ADAS, and this is just an example on the right side for various functions like lane keep assist, automatic emergency braking, adaptive cruise control, and blind spot warning. And the criteria are listed there. So we're making good progress actually promoting this, as I said, through the legislators and in various circles. And we hope that it's going to take the same path as the one on the left side, which was the government safety ratings for crash worthiness on vehicles. And you can see them on all vehicle parking lots, and you can see them, dealer parking lot or dealer lots. And you can actually read through that when you purchase a vehicle. So our attempt is to also educate consumers and ultimately also perhaps the OEMs and the tier ones to understand this communication with the end user. Coming back to the PAB testing and the Vela, the software solution, if you look on various published information, as I said, on dealer lots, literally you can read on the sticker information like the one on the left side, the dealership disclaimer for radar-based AEB system. And it comes back to the comments that I was making on SOTIF. The radar in this case performs as intended. No, again, defects or any limitation from that perspective, but it doesn't achieve the overall safety functionality intended. So you can see that the vehicles that are stationary or moving under 6 miles per hour cannot be detected. Objects or pedestrians on the road, that's a major limitation. Vehicles in your lane that are oncoming, and so on. So those are limitations, again, that you can see as a disclosure, if you want, on some of the vehicles being sold to consumers. With the LiDAR, we certainly plan to and do address currently some of these limitations as listed on the right side, including low light conditions, including objects in the background, shadowy condition, and the distance measurement that we are providing, as I mentioned before. In order to make the point, as I was discussing earlier with Bruce, we are engineers, so we don't want to limit everything to statements, and certainly wanted to put the data and facts behind this. Excuse me. So we ran some testing and measurements that I will present quickly. But the idea was to combine or to compare various technologies. Camera and radar does exist currently on vehicles. So we selected one of those vehicles equipped with ADAS camera and radar based, and then a LiDAR based ADAS technology on a vehicle. And this is just another list of the PAB functionality. Again, supporting this testing that we conducted. And here are the results. So this is the set of results for the LiDAR-based PAB system. And it's done scientifically in perfect we're following directly the NCAP protocol for KAB testing with dummies representing adults and childs in terms of the size, different overlaps with the vehicle, different vehicle speeds. And the point here is you see green in all these categories because the vehicle stopped 1 meter before collision. So 1 meter, we deemed that as a kind of safe distance to impact. And all the LiDAR-based systems or the LiDAR-based vehicle performed well in all those conditions. In case of camera and radar, we had collision in several instances. So that's one aspect of the testing that we conducted. The other aspect is that if we did the test in low light conditions, which are very representative for the real life, that resulted in even more drastic differences between LiDAR and camera-based systems. Certainly LiDAR has its own source of light to the laser beams. So it comes without saying that there is an inherent advantage there for low light conditions. And again, if you go to our website, I can provide that link, but there is a very comprehensive set of tests described there with video clips associated with those. And you'll see the vehicles that we used, and you'll see, again, the results that I'm succinctly presenting here. But the point was decrease the vehicle speed with the LiDAR system to this safe distance to impact, which we deemed 1 meter, and that is certainly sufficient. Regarding the approach that we take with Vela for the general architecture, it's pretty classic. I'm not going to spend too much time here, but I wanted to just reiterate what has been earlier discussed, or the question that was coming up earlier, which pertains to various PAB scenarios. So under pedestrian automated emergency braking, there are several scenarios that are considered representative. And one of them is certainly this one shown here, which is a potential bicycle collision on an unprotected right turn. Another one is a person falling from the sidewalk into the vehicle's path. Another one is a child emerging from behind a parked vehicle, so relatively small size pedestrian. Another one is certainly the incoming vehicle or oncoming vehicle actually blowing through a red light during an unprotected turn. And with that, again, I just wanted to do a recap of some of the things that are considered under KAB. It's not just the straight driving condition and a specific, again, one single traffic condition, but kind of set of those conditions, very representative for real life. What we are proposing as a result of the experience that we collected is actually trying to address a lot of the data that you perhaps see, but I'm not sure how much we are able to process this truly and associate this information also with the type of testing that we see in NCAP and in other regulations. So this is again just real data from a variety of years spanning over up to 2020. Actually, this is limited to 2018, but the percentages are pretty consistent. And so there is a significant increase actually in crash fatalities related to pedestrians. As mentioned before by the previous speakers, pedestrians are certainly one of the, I mean, they are the area of focus along with the other vehicle road users in terms of protection by automated driving. And 17% of all crash fatalities are pedestrians. Very telling is the fact that 76% of those pedestrian-related crashes occurred at night in dark conditions. And then I think various organizations are highlighting the same thing, the limitations of the current systems and the limitation of the current requirements relate to this low light or nighttime conditions. NHTSA itself conducted specialized testing on those as early as 2017. And the results are summarized here. I'm just flashing through this because the message is very clear. When you see something in white rather than in green, it means that that particular test described in that category resulted into impact. And you see that there are a lot of white cells here. So a lot of those tests were actually resulting into impact under various conditions as summarized in those two tables. Again, we have a white paper on this. You can look into the details of this. I'm bringing that up because I'm reaching my conclusion here and the end of my presentation. With all this supporting information, including our own testing, including NHTSA's testing, what we are recommending strongly is the NCAP should start considering low light conditions for vulnerable road user testing, PAB testing, and that specifically means less than 1 lux ambient illumination. I don't think there will be much argument in terms of how representative those conditions are for real life, either in urban environments or rural environments, country roads, surface roads. So it's certainly a logical approach and something that needs to happen, and yet we suffer from not having it included in the current validation and testing. So with that, I will stop sharing and thank you very much for your attention.
Thank you very much, Mircea. You really touched on a lot of cool things that we've been talking about today, and it'll open up our discussion a little more. And I think I want to start out with the way that you were talking about the ADAS systems in supporting ADAS systems, not necessarily only autonomous systems, right? It's a combination of both. It sounds like the way you were describing it, that you were doing a lot of sensor fusion yourself. Is that part of your what you're offering as part of your solution?
Yeah, I mean, certainly we did that type of work for various purposes. An example is in a certain case we colorized, so we put color on the image or point cloud of the LiDAR in order to match better the camera output and also allow for better functionality with respect to object classification and all the other functions that the software stack needs to perform. So that's one example of actually having various sensor modalities working together. Same thing with kind of heat map, allowing you to actually detect live components, if you want, into the scene, which is crucial, right? And especially in conditions where you drive at night on a rural road and you're having potential wildlife or other undesired crossings. So that's another approach that we took. We fuse and are focused on providing the system solution on the vehicle among the LiDAR sensors distributed around the vehicle, because they are of a different type, as Robert can confirm. The sensor suite itself includes, as I said, the short-range sensors that are targeting blind spot detection and in general eliminating blind spots around the vehicle, along with the long-range sensors that are addressing higher speed requirements and various other use cases. So yeah, I mean, the answer is yes, we look at that. In general, as I said, and as expected, our approach is LiDAR centric for the reasons that I mentioned.
Very good. I really like the SOTIF table. That was very interesting. And the idea of trying to start putting some numbers around the different systems. one thing for the PAEB table where you said at 50% overlap, what does that mean at 50% overlap?
Yeah, I think, again, everybody who's actually performing the NCAP tests or
they know what that means.
Testing, and yeah, I mean, you start to become familiar with that kind of crash-related assessment, and it means actually, if you want 50% in simple terms, means that the pedestrian dummy or the adult dummy used in that simulation is located on the center line of the vehicle. So basically, as the trajectory of the pedestrian crossing is perpendicular on the vehicle trajectory, the dummy is 50% into its path, so to say, overlapping 50% with the frontal area of the vehicle, basically.
Okay.
That's
yeah, that makes sense. We had some earlier discussion about cost issues, about for manufacturers or feeling that, you know, they have to keep the costs down for anything they put on their vehicles. As you know, having worked for manufacturers, you know the story. Will solid state help reduce the cost of LiDARs?
Yeah, I think the cost reduction initiative, and specifically in our case, is not necessarily related to one type of sensors only. It's not only related to the solid state. As an example, the micro LiDAR array that I mentioned, the MLA, which I mentioned in my presentation, that is essentially a chip-like or system on the chip type of approach, which can be used, so that component can be used either in rotational LiDAR or in the solid state LiDAR.
Mm-hmm.
It benefits all the product line, not only a specific product.
Mm-hmm.
So every product line within our portfolio benefits from that. That was the idea. And I think, yes, that's one cost reduction approach. We certainly rely on our customers to bring the volumes in the range that actually drives economies of scale and helps with the supply base and so on, to create momentum around those components used in LiDAR and reduce cost further. And we also rely certainly on legislation, as I mentioned, to actually support the introduction of LiDAR technology for safety purposes, and that will further reduce the cost. So it's the general evolution that you've seen in starting in systems as early as ABS or anything that started decades ago went through those various steps to reach the current state in terms of reliability, durability, cost, and all the other requirements.
And bringing computers into cars. That's what changed everything, though, didn't it? That was allowing ABS to even work, right? Mm-hmm. One of the things that actually I wanted to ask Tom if he had anything you wanted to add. Thomas spent his presentation talking about LiDARs, so I wondered if he had anything you wanted to add.
Yeah, it was a great talk. Thank you very much. I guess what I found really interesting is seeing how far you guys are going in really looking into the specific use case of LiDAR for advanced emergency braking. I've been on a panel with Adasky before, who are a thermal camera company, and they've also spoken kind of at length about some of the challenges with advanced emergency braking systems in low light conditions. But it's really interesting to see how much further you guys have gone. You know, you've actually built and done comparative testing of systems. Is the purpose of that research, is that to help your customers to make more informed decisions on, designing their sensor suite, or is this actually a software service that you plan to offer in addition to selling the sensor hardware?
Yeah, thanks, Tom. Very good comments and certainly very helpful in clarifying also our intent. Our intent is actually both. And the educational aspect doesn't pertain only to our customers. It pertains to the entire community, as I mentioned, which encompasses everybody from the end user, the owner of the vehicle, if you want, either an individual owner or a fleet owner, and then you go to the entire chain back to the manufacturer. But in between, you have dealerships, you have service organizations that have to service the vehicles in the field. You have, again, the very important component of this and our educational work is legislation supporting this. Without the legislation, and no matter how cost effective our systems are, there is still a little bit of an obstacle for introducing the technology because the cost aspect. So again, as Bruce mentioned, $1 more is $1 more on the bill of materials. So that has to be justified and supported, hopefully also through the legislation that enforces the need for not a specific technology. Again, it's not about the technology itself, it's about addressing those safety requirements that I mentioned, the SOTIF aspects through no matter what solution you're coming up with, but they have to be addressed. And we claim that we have a very good solution. That's certainly our thesis here, but there are many others that, and if you reach the end result, it's all good. So that's the answer to the educational aspect. And the second part of your question, if you don't mind, was related to if we plan to continue the activity, or
is this something you're going to go? I guess one might kind of assume that providing things like an advanced emergency braking system would be the responsibility of a traditional tier 1 automotive supplier. But it looks like you guys are doing quite a lot of work there yourselves. I was wondering if that was actually a product you plan to offer to OEMs.
Well, that's such a great topic. I mean, probably it will exceed the time that we'll have in 5 of those, at our disposal. But the question on how to distribute that type of responsibility, it comes with responsibilities, not just, as you know, the intent of supplying or not a specific function or a specific component. That is deeply addressed through the ISO 26262, which is the functional safety. And we are currently in the space of being an ASIL B in a D system, ASIL B of D, right? So that's where we operate as a tier 1, tier 2. Yeah, that's a very good discussion topic that takes place through this design interface agreement, the DIA phase of the functional safety discussions that certainly take place when a tier 1 or a tier 2 works with an OEM, and that defines actually who's doing what and what are the implications of that. What we want is one aspect in all this, but what the world wants us to do is another aspect. So we have to kind of get to a happy marriage there. So.
Joaquim, there was a lot of regulatory stuff in his presentation.
Yeah.
Did you have anything you wanted to add?
Yeah, I just wanted to emphasize that I really like the approach of the ADAS rating system. I heard of it before through IMTS, and I'm very interested in that. Maybe one comment in this regard is to have maybe a dialogue with insurance companies also on this. I don't know whether you already got traction on the insurance side, or not only on the legislator side. Have that maybe would be worthwhile considering.
Yeah, I mean, as I said, our safety outreach and safety advocacy, I had a more detailed slide that was actually including the name of the companies that will directly address your question. But DECRA is an example, and
yeah,
the organizations like AAA and so on are all included.
Right.
So the answer is yes, absolutely. That has a impact from that perspective. We hope a beneficial impact. So
yeah.
And we worked with IIHS, which is cumulative result of talking to 20 insurance companies in all the insurance companies, because they have all of them on board. And we conducted jointly testing, and the idea was to, again, make the point that yes, you get significant benefits from that perspective as well. Personal injuries being reduced, deaths being reduced, those are the extreme cases, but fender benders and everything else. And we also talked to the Society of Collision and Repairs, because in a way affected by that. And it's interesting to understand that actually it's not a revenue reduction necessarily, because you're eliminating those collisions or all these things happening, but actually it can be a tremendous revenue opportunity if you think about the aspects of calibration or recalibration and servicing those technologies in the field, similarly to cameras and radars and so on. So yes, it's a continuous education.
And then one maybe input for the rating system, not only to do this with brand new sensors, but also to do the rating over the life cycle of the sensors. So to also get a life cycle behavior that could be potentially interesting to consider.
Yeah, great point. There is a intrinsic and extrinsic calibration topic there. There is a self-calibration topic to compensate for some of the changes occurring over the lifetime of the sensor and vehicle. It's not sensor itself, but it may be that environment around the sensor changes. So that's a great point.
Joachim, I'm glad you brought up the insurance question, because one of the one of the attendees was asking about that a little earlier. We're running out of time here, but I want to get two last questions that I want to ask everybody. And of course, they're pretty loaded questions, so you can answer them in any way or form you would like. First one is, when will automated vehicles be available for consumer purchase? Robert, let's start with you.
I think that we will see more and more incremental parts of autonomous systems coming into personally owned vehicles. And like I said in my talk, I think full true level 4 systems are still several years away, I believe.
As in decades, or
not as in decades, but I mean, time will show. I mean, if we can actually achieve truly level 4 autonomous driving, I believe we can, but it's certainly some years out into the future.
Yeah, Tom.
Yeah, I think I'd mirror the comments of Robert there. I think you can probably. You could argue that there is some level of autonomy available in vehicles today, and I think it's probably going to be quite an incremental change. But yeah, I think kind of level 4 could still be quite a ways off.
Mircea?
Some levels of, certainly I agree with everything what's being said, but some level 4 vehicles, and level 4 as in certainly a limitation to the ODD. So the operating design domain is limited in case of level 4. And if you think about retirement communities like the villages, for instance, where you have a shuttle operating at 35 miles an hour max, as an example, that is in place today. So you have those things happening in Florida and other places, in the Bay Area as well. So some are in again, operation today, but as you advance and remove the limitations for sure toward the level 5, I think, time horizon becomes certainly more in the decade range.
Yeah. And Joachim?
Yeah, so I have a lot of dialogue with those that are working on this. So it looks to me that the ambition is to become level 4 ready and also process ready, certification ready within this decade. So let me say it this way. And then what Mircea just said is very important, that we need to distinguish what type of ODDs, right? So is this, I think if we are saying It will not be everywhere, but it will be specific types of ODDs, then definitely this decade. But if we want to see this in large volumes, there has to be a lot of preparation being done in the development processes, the certification processes, legislation, and the test infrastructure upgrades. And that requires money, time, and effort. But I'm confident that it will happen this decade.
On that part of it,
Yeah.
Okay. Last question. We haven't talked about this today at all, and I think it's just been brought up a little bit. Mircea was talking about low light situations, things like that. But what about weather? Where does weather rank as a corner case? All the testing has been done in really nice weather, and you don't see that. Robert's been doing some testing in Ann Arbor, so he knows what bad weather is like. Can autonomous vehicles actually overcome really bad weather?
Well,
Yeah.
Let's start with Robert. Robert?
Oh,
Yeah.
go ahead.
Let's start with Robert.
Yeah.
I think it's obviously a lot more difficult when it rains heavy rain, especially for the perception system. So I think first, the previous question, I think that achieving true level 4 autonomy, I think under good weather conditions is already challenging enough, and then adding really heavy rain, for example, or even snow into the equation will make it even more difficult. So I think everything is possible. But I think that's even further away than true level 4 autonomy under good weather conditions.
Very good, thank you, Tom.
Yeah, thanks for asking the question. As a Brit, obviously talking about the weather is kind of second nature to me, and it's a topic close to our heart over in the UK. It's quite timely, actually, your question. I'm hosting a panel discussion at AutoSense Brussels in 2 weeks' time on the effect of adverse weather on autonomous vehicles. It's something we work on quite a lot at TTP. We're looking at ways of making sensors robust to weather, I guess, there's kind of a whole load of conditions that can affect how the sensors operate, and even things just like condensation and water on the surface of sensors can affect them badly. I won't say which company, but I was on a drive in an autonomous vehicle, a test drive about 2 years ago in a place that doesn't rain very often, and they had this kind of freak rain shower, and then I could see the SLAM algorithm had us like teleporting through buildings and stuff while we were in it. It was really interesting to see just how much a bit of dust and can affect the calibration of sensors. So it is an important issue to address. I think ultimately it's going to require kind of a sort of multi-pronged attack. I don't think there's going to be one killer solution to making all of these systems robust to weather. I think over time we're going to have to develop systems that keep the sensors clean so that we can trust their data. But yeah, it's going to probably need new technology. I don't think we can put wipers and liquid feeds all over an autonomous vehicle to keep all of the sensors clean and operating at all times.
Very good, thank you. Mircea?
Well, I was about to jump on the question initially because I just wanted to kind of put a little bit more color or qualify it a little bit. What is your expectation when you ask the question? Because I'm saying that because in a pour down conditions, or whiteout condition, the human driver will stop the vehicle. So do you have more expectation from the autonomous driving system? Because if we do, that may become unrealistic. And if our goal is to meet or exceed to a certain extent, certainly what a human driver can do, I think that capability will be in place. Eventually, maybe some of it is already there. So that's one aspect that I think we should try to understand. I don't think it's realistic to expect the autonomous driving system to handle a whiteout condition entirely and just continue driving like it's a beautiful sunshine day in California. So I think that's one That's one aspect. If you're talking about specifically sensor technology, we look at water absorption coefficients that are related to the wavelength of the laser beam provided by a specific LiDAR technology. 1550, for instance, versus 905 have significant differences. There is more water absorption with 1550 that can reduce some of its performance characteristics. So those are things that are being considered, but I just want, again, at a very high level to understand what the meaning of the question was actually, because again,
we have seen so many drivers who will drive in whiteouts, who will drive in near whiteouts and get in their cars. And, you know, I always say that, you know, if I was driving an autonomous vehicle and tried to do that, it would just say, nah, we're not driving today. Today, you may want to drive in that bad weather.
I hope it will.
We're not going to drive there.
Yeah, in that case, I don't think the limitations related to safety will be related to the perception system, but more to the traction coefficients and aspects of the, you know, vehicle being on a, you know, snow-covered road and all that. I mean, that's a completely different aspect.
There's,
yeah.
Go ahead. I just want to chime in here. So there is also one aspect is whether the infrastructure can help. So, for example, if you have very detailed information about the road surface and very detailed information about the quality of your tire, you know, then that might enable you to give support even in difficult situations. So I think it's a very complex question. So first of all, I need to be honest to the consumer and say, well, my system cannot handle it, and you need to drive yourself, or we are learning over time to handle these situations by having the knowledge through the sensors, having the simulation models in place. Mm-hmm. It's an iterative process. And if everybody agrees these situations can be handled up to that degree, well, then it just gives another extension of autonomous support. Right? So that's how I would see it.
Very good. Thank you. Yeah, thank you very much, all the speakers. It was a great discussion today. I really learned a lot, and I think our attendees learned a lot as well. It was it covered so many different areas, and almost all the areas that I really kind of wanted to touch on in terms of where we are today in terms of autonomous vehicles. Again, we want to thank our speakers, but also want to thank our attendees. Our next conference is going to be coming up on November 17th, the 14th Annual Inside China Automotive Conference. Also, I wanted to, as always, thank our affiliates. We could not do the conferences without them. We, again, thank you to them. Please join us on our LinkedIn site, and the presentations will be available this weekend. Thanks again, everybody. Take care.